Hello, everyone, and welcome to the second day of Espressif DevCon25. Yesterday, we had a day full of deep technical talks available if you didn't watch it yesterday during the live. We will also upload into individual files, so you don't need to worry about having 7 hours and a half long video to watch. And for today, we prepared something different, so something special. And for the first time, we will be here live for a longer time. We will have about, I don't know, maybe 3 hours long live. Yeah, with some breaks. So my name is Pedro Minatel. I'm from Developer Relations here at Espressif. And today I will I will be the host as well. I will take questions from from the audience, and as well help during this live session.
Yeah, and I'm Ivan Gortkov. You probably know me on GitHub by my handle IGRR. I'm VP of Software Platforms at Espressif, and today I will be guiding you through the process of developing an application for ESP chips.
Yeah, so let's keep the YouTube chat alive. So please ask questions, do comments, or eventually even ask some new feature requests. So this is a good opportunity for that.
Suggestions are welcome.
Yeah, so we are really here to listen to you and as well get some feedback about your experience using ESP chips. All right, so what's the plan for today?
What's the plan? Okay, so we will try to go through the process one might go through when trying to develop a new application for ESP chips. And of course, it's going to be a bit artificial scenario because we only have 3 hours and we need to have something working by the end of those 3 hours. So we will definitely be doing shortcuts here and there, and it's not going to be don't follow everything that we do today as an example of what you should do if you're developing a production application. I will be mentioning during the talk that there are some things that we are just doing as a quick shortcut. The actual application we're going to do today is going to use the ESP32P4, and we will try to make an IP camera, essentially a network-connected camera.
Yeah, so and we will introduce some of the new peripherals on the P4. So if this is your first time seeing like the P4, that will be the best opportunity for you to know what the P4 is capable to do.
Even though we will probably not even... Okay, we will scratch the surface, but we will not show all the capabilities of the P4. So our application does not involve anything related to displays. So that is another big thing that P4 can do. We will not be using MIPI, but still, I hope that you will learn something from today's session.
Yeah, of course, we have like only 3 hours. Otherwise, we'll be here like for a very long time if we want to introduce all the new peripherals. And all right, so before we get started, the YouTube chat will be the way to get in touch with us, right? So I will manage the chat. So please, if you have any question, comments, post there, right? And I will try not to interrupt Ivan much, but if I find any interesting question or comments, I will bring it to the table and we can discuss about it.
Yeah, absolutely. I think it's very important. If something is not clear, if we are just skipping some steps here and there, if you have a question, then don't hesitate to ask.
All right.
Okay, so we can get onto let's say the hardware part first. That's probably the simplest part of our today's session. We start with the ESP32P4 development board. This is called Function Evaluation Board. The one I have has a slightly older version of the chip, but it probably doesn't matter at all for our purposes. Pretty much everything that we do will work on the version of the chip, which is the mass production version.
So should we start with LED blink?
I think that, well, first, the board actually doesn't have a single LED on it. So as much as LED blink is the go-to for starting a new project, we'll probably have to do something different. Given that it's a camera application, I suggest that our blink today is actually getting a frame from the camera. That I think would be appropriate, right? So for the camera, I just have a USB webcam. It's a USB 3.0, I guess, Logitech camera. And the connection is going to be very simple. So the P4 board has three USB ports. These two are actually the same USB port. This is the USB high-speed host port. This is the USB high-speed device port, so they share the same signals. And then there is a USB full-speed port, which we are not going to use. And in the middle, there is the USB serial JTAG, which is the way to flash and debug the chip. So we're going to connect that to USB, and we are going to connect the camera to the USB host port, and that's pretty much all the setup we have for today. At some point, we'll also connect the Ethernet cable once we get to the networking part. So I think we can move on to the screen sharing. My software setup for today is I'm using Cursor, which is a fork of VS Code, but pretty much everything that we're going to do applies to VS Code as well. The interface is the same, just a few keyboard shortcuts are different when you start using the Cursor. I have the ESP-IDF extension installed from the marketplace, and aside from the ESP-IDF extension, I also have CMake extension for syntax highlighting in CMake files, and I have the CLangD extension installed, and CLangD is for syntax highlighting and navigation in C code. So that's pretty much everything that we're going to use. And we start off in a blank project, blank workspace. I have just the directory created. And let's first move on to how we actually get frames from the USB camera.
All right, so we are talking about USB cameras, but could be, for example, MIPI camera as well.
Yeah, it could be. If you followed yesterday's broadcast, you saw that the ESP32 P4 now has a wide variety of components that provide you abstraction layers over all of those different ways to connect cameras. So there is the ESP video, which is built specifically so that you can connect to USB cameras, you can connect to DVP cameras with parallel interface, you can connect to USB cameras, and it will work exactly the same way in software. So that is one advantage that the ESP video component brings. And then there are even some higher level components, the ESP capture that we also featured in the talk. Today we will use only the USB camera. So we can use the ESP video, but we can also use just the underlying driver for USB cameras, which in our case is called USB Host UVC. I will show you that if I want to have the UVC driver, I can go to the ESP component registry, and I can find here this USB Host UVC component. So that is the USB host class driver.
Yeah, and I will share the links here in the chat to be easier.
So we will. This is our starting point. I think before we get into actually starting to use this component, I want to explain one more thing about the components that I'm using. So if you were following yesterday's broadcast, there were quite a lot of different components related to streaming, to multimedia, and you may have a question like which one you should use. And if you were building this as a production application, I think you would definitely use the, for example, ESP video or ESP capture components. I wouldn't say that it's for sake of simplicity, because we are definitely getting into some more complexity by using the low-level components. But to make this this session more illustrative of what the actual coding workflow will look like, I wanted to do this with a kind of bare lower-level components this time. But don't take this as a suggestion that if you are going about developing an IP camera, this is the way to go. I would suggest you to check the talks that we had yesterday about ESP video and ESP capture and apply those components, because they will solve a lot of problems that otherwise you will have to solve yourself. So we start with this USB host UVC driver. And the way to add this driver to the project, normally if you already have the project, is to run this IDF by add dependency command. You can also use the built-in component registry view inside the IDE. Then you will just have the install button there. What I want to do so that we get to Blink in a reasonable amount of time is to actually start from the example of this component. So the component provides two examples. We can see here the basic UVC stream and camera display. Now, we don't have a display, so we're going to start with the basic UVC stream. And to create a project from this example, I'm going to copy this command and then go to my VS Code window.
Okay, so since we don't have any display, do you have any plans on how we will get the frames?
Yeah, it's an excellent question. Getting the frame and just having that frame in a memory buffer on the P4 doesn't do us much good, right? We also have to see that we actually got something reasonable. I think the example out of the box saves the, it's probably not written here, but the example out of the box saves the data onto the SD card. So we will just go and create the example now. I basically just will run this command, and I should get the directory basic UVC stream, so we can take a look at the code a bit. By the way, for folks who are watching us, I'm screen sharing this, and I have my default light theme installed in the editor. If you don't like how it looks and you prefer me to increase the font size or switch themes, please please leave a comment in the chat. Okay, so this is our example. We haven't built it yet, so there are a bunch of red squiggle lines here. But we can see that there is some code there about connecting to USB, and then there is code to handle frames. And we aren't actually doing anything with the frames. There is this command process the frame data here. So the example indeed doesn't save the data. So we will have to figure out how to do this. And now we have lots of possibilities actually to do this. So we could connect a display, we could put the image onto the display, we could save the image to the SD card maybe.
Yeah, but maybe removing and adding to the computer would be maybe quite tricky.
Yeah, then we have, every time we run something, we have to take the card out, put it in the computer.
Maybe some more.
I remember that a while ago when the ESP-32 first launched, we were just trying to make the first demo application that involved DVP parallel interface cameras, and I think it was 2016. And this is what the hardware that we make looks like right now. And I have a photo here that I will just bring over. This is what the hardware looked like back then. So we had I think this OV6750 or something like that camera connected with a bunch of breakout cables to this was one of the first ESP-32 development boards, and this was a demo of a QR code recognition application. And to debug that, because I didn't have the screen driver yet, now we have BSPs, and it's very easy to get display working with BSPs and LVGL and all that. So I had to resort to printing the frame into the console of the serial port and using this kind of different characters to represent colors. And I think this is probably the first selfie that was ever taken with an ESP-32 chip.
All right, so this is part of Espressif history.
Yes, and this is also an easy way to see what the frame is, but it's probably not the best because, as you see, the quality is kind of not great.
But I can recognize that. That's you.
Yeah, that's me. So we will do yet another thing, and that is to use semi-hosting. So semi-hosting is a technique when you connect the computer and your development board, and the code running on the development board can offload some of the operations onto the computer. And the most common one that you would usually offload is console output, so that your output goes directly to the console. Well, we have the monitor, so that part is not a problem for us, but also file I/O. So basically, the code running on the development board will be able to open files and read files and write files, and files actually will be on the computer. And this will be all managed through the JPEG connection using OpenOCD. And it looks pretty complex, but actually, as you will see, it's going to be pretty simple. So I will start with this example, And let me first just compile it. Oh yeah, okay. I forgot that actually my working directory right now was still that top-level directory where I have everything that's EDC25cam. There's a container for everything we're going to do today. And indeed, there is no CMake list file there, as the IDE tells us, because the project is inside that basic UVC stream directory. So one way that I like to use VS Code and our VS Code extension is to organize things into workspaces. So a workspace can contain multiple projects, and this will actually be very convenient for us as we go through the steps of today's development. So first of all, I will save the workspace. That creates a workspace file, and in the workspace file, we see that we just have this folder. Now, what I actually want, I want to have the folder for the example that I just created. So I will add the basic UVC stream here. And this path, sorry.
So maybe one important question that might appear now, like how you're planning to share the code or everything we are doing here?
Right, that's an excellent question. I think we will set up a repository, a Git repository, where I will be pushing all the code that we developed today, and then it will be available during the broadcast, and it will also be available after the fact.
Right.
I think we do the Blink first, and then I set up the Git repository, and then we push it. So I've set up the workspace now. I have the basic UVC stream folder, and I have just the overall workspace folder in case I need it. So here is my basic UVC stream. That's the example I just created. And then in the extension, I will use the command to pick a workspace folder, and here I will pick the basic UVC stream. So now everything that I do with the extension, like building, flashing, monitoring, it will happen in that folder. And I think we probably want to do one more thing, and that is to select the target. I'm using ESP32P4, of course, and I'm using it through the built-in USB JTAG. So now the target is set.
And on which version of ESP-IDF you are?
Right. Now I'm using just the master branch of ESP-IDF, which at the moment, if you do git describe, it's gonna say 6.1 dev. So we're kind of preparing for 6.1. 6.1 is going to be a long way ahead. We are now developing 6.0 release, but the branching from master has already happened. So I'm just using the recent enough master branch of ESP-IDF at this point. And that's it. I think we will do. Okay, we have set the target, so now we can build the project. The question in the chat, any plans for EU Cyber Resilience Act compliance, long-term security updates as bomb vulnerability disclosure for ESP-IDF? Yes, that's totally something that we are doing. I will show you the article we have at the developer portal. Okay, sorry, I can switch to the real board right now. But yes, we definitely have the SBOM support, and there is a page that we have that I can show a bit later, where we have the status of all the vulnerabilities that have been detected in parts of ESP-IDF, like libraries such as embed TLS and JSON and so on. So you can use SBOMs. There are also vulnerability scanning tools that you can rely on. And in terms of long-term security updates, we will definitely have something to share this year. Okay, and then just one more thing, I forgot to set the port. we were going to use this port, and now we are ready to flash.
That's another comment that it's a beautiful and terrifying hack.
Yeah, I'm not sure what this really, what specifically this was related to, but I'm pretty sure there will be some terrifying hacks today. Okay, so we have the example running, and as you can see, it's currently telling us that it couldn't find frame format 720 by 1280 by 15 frames per second. And this should definitely be a format that cameras support. Although, maybe now that I'm looking at this, I think the problem is that we are asking it for 720 by 1280. So it's like if we were doing a TikTok video. So we probably need to ask for 1280 by 720. And that's probably something that the camera will actually be able to support. So we will go and find the configuration of the camera. Yeah, so this is the place where we pass the configuration to the UVC driver request in a certain format. And here the horizontal resolution was 720, so I'm going to flip it around and set it 1280 by 720. And I'm going to try again.
By the way, about the terrifying hack was
about the SKR. Yes, it is. Okay, so we have something working now. We see that at least the camera, the example says that it's getting frames. We don't see those frames yet, so now it's time to get to the semi-hosting part.
Let's put that not here, maybe.
Okay. So in order to use semi-hosting, what we will need to do is first to initialize it, as pretty much anything else that you want to use. And for this, I'm going to go just somewhere to the beginning of AVP main function. And I will add the initialization of the semi-hosting VFS driver. VFS is the virtual file system infrastructure in ESP-IDF, and it lets you mount different types of file systems. Usually you're dealing with FATFS or LittleFS file systems. Semi-hosting also kind of provides a file system. We will need to make sure that we add the VFS component into the requirements list of our main component, which is where we are working now. This allows us to actually access the include header files that are offered by VFS component. And then in the example, we are going to include ESP-IDF semi-hosting, and let me just run. So one thing I want to note here is that right now, if I start calling the functions from ESP-IDF semi-hosting, I will actually still not get code completion and highlighting. Actually, I think right now I'm not getting code completion and highlighting at all, because I think that CLangD, our language server, isn't configured yet. I will do one thing here. I will add a CLangD file .CLangD to the project. For some reason, my snippets aren't working. So I'm going to copy it from somewhere else. This is the very simple CLangD file, and I think now if we okay, so now you see some squiggly lines in the source code. So now the language server is working, and we actually can do code navigation and so on. So you see that the ESP-VFS semi-hosting, is it semi-host or semi-hosting? Yeah, it's not being found, even though I've added the component to the CMake list file, and this is because I've only added to the CMake list file as a dependency, and the CMake hasn't run yet. So I will also run the IDF-Py reconfigure task What this does essentially, it kind of does a shorter version of the build. So it runs CMake, but it doesn't run the whole build. And this is enough to let the IDE know that that component is actually present. Maybe I'm missing what the name of the component is though. Oh, sorry, the name of the include file, ESP-IDF.
Yeah, and when dealing with components, this is a command that we use a lot.
Yeah. Okay, so now I can go and add. Yeah, sorry, for some reason I got the wrong file name. It's not ESP-VFS semi-hosting, it's ESP-VFS semi-host. Yeah, now it's green. Okay, so that built successfully. So we have VFS semi-hosting initialized in main. So this is our APP main function. This is the semi-hosting driver initialization. And now when we get the frame, we can actually save it somewhere. So I will create a directory in my project called output. And then inside the function that receives the frames, what we will do here is we will just open a file. Okay, so that's looks about right. This way, all the frames will write to the same file. So maybe I will actually create the file name. So now different frames will be saved into different JPEG files. And that looks about it. So I think we can try to run it. Oh yeah, there was a comment in the chat about ESP-VFS semi-host. Thanks. And something's crashing, so we'll take a look at what's that. Oh yeah, okay. So if you see that what's happening is that there is an error message that says OpenOCD not connected, and there is a reboot, and that is because I actually used this ESP error check macro that when it encounters the error, it just aborts the program. Now, this is where I deviate from what I would recommend for sort of a production-ready application, and in general, aborting on an error is something that you only do if you thought about this and you decided that that's probably the only way you can handle that error. And normally you take the error and you propagate somewhere to the caller. In this case, we only have 3 hours, and if I'm going to be doing all the error checking properly, I think it's just going to be a lot more code. So I will, in some cases, take shortcuts today, and I will be using those ESP error check macros instead of the more correct error propagation. In some cases, I will do error propagation where it's easy to do. Anyway, so the error message was that OpenOCD is not connected. So we need OpenOCD, and we do that by going to the OpenOCD manager and starting OpenOCD. Note that we don't actually have to start GDB, like actually connect into a debugging session and do step-by-step debugging. Semi-hosting only needs OpenOCD to run. So now I can go to the monitor. Okay, so now the application is running. We are getting some watchdog error. Oh, okay. I think I know what the problem is. Yeah, sorry guys. While preparing for the talk, I was a bit messing with my installation. So give me a second. Maybe we can.
That's the beauty of being live. Like we are having the same situations as we have on our daily work, right? In the meanwhile, there is a question here. How about the API changes from IDF 5 and 6? Can we expect many breaking chains in the future? What's the best way to keep up to date with new features? All right, so for all new break changes that we introduce, we have on our documentation the migration guide. So that's the first point you can go through and see first of all, what changed and how you can proceed to keep it updated. So this is the first document that you should read, the migration guide, and as well I follow all the release notes and as well the documentation itself. And talking about documentation, we have a new platform called CDP, which stands for Centralized Documentation Platform. It's documents.espressif.com. I will share here in the chat, and you can find all the documents related to the SOC, including like TRM, datasheet, and many other resources, including the IDF programming guide and certifications and so on. So this is the place you should go if you are looking for any documentation about our chips. I will share here in the link.
Yeah. In addition to that, there is a pinned GitHub issue in ESP-IDF repository right now, which lists the breaking changes that are going to happen in IDF 6.0. So even before we actually publish the breaking changes or publish the IDF 6.0, you can see what's coming up. I think most of the changes in IDF 6.0, they're related to removal of functionality that has been already deprecated. And aside from that, there are not too many breaking changes that actually will require migration. So mainly if you were using drivers that, for example, have been replaced by the new recommended drivers, then that would be something that you would have to adapt to.
I see.
Okay, so we are definitely having some demo effect here because I was totally sure that this is going to work and going to work really well. So I will do some troubleshooting here.
And is this related to the semi-hosting?
Yeah, this is related to semi-hosting. So for some reason, I am not really able to start the OpenOCD properly, and this may be related to the fact that I'm using an older version of the board. That is really weird because I tried the same thing yesterday and it did work fine. Okay, so at least we got into the debugging session. I guess now if we run it. Okay, yeah, our blink is definitely not going as smooth as I wanted it to go. Yeah, we're still getting those weird issues. Okay, let me try something else. So I will close the editor again and just come back in a second.
All right. In the meanwhile, I'd like to know if there is anyone here watching us that is developing some IP camera solutions, like baby monitor or something that this live could be helpful, or maybe I don't know. We are giving you inspirations for a new product. So please leave here in the chat if any of you are thinking or working on IP cameras or anything related to cameras with ESP32.
Yeah, and also, if you are working then on those, then note that we do have some camera solutions coming up in many of our frameworks. So, for example, we mentioned during the keynote, I mentioned the Rainmaker camera solution, and that is a great way to make a cloud-connected camera application where you will not have to worry about all of those things that otherwise you would have to develop manually. As well as Matter 1.5 specification introduces cameras. So if you're building Matter-connected devices, then when Matter 1.5 support is released, you will be able to do that. And again, that framework takes a lot of the challenges that you would otherwise have to face. All right, so I just restarted my environment. And we will try building the project again. So now we're getting the camera, but then we are getting a watchdog reset for some reason while trying to save the image from the camera. Failed semi-hosting operation. Yeah, this is not the outcome I expected. Anyway, well, the good news is that we have the stream apparently working. The bad news is that we can't easily save the images yet. We can always fall back to the SD card. We can always fall back to printing to the console. Like it. Yeah. I think we will get it eventually working. Let me just try one thing. I think that I just want to make sure that semi-hosting does work, in fact, when we do it from the app main. We kind of also have to move a bit faster because we only have 3 hours and we actually have quite a lot of work to do. So if it doesn't work, then I will just assume that we got to the blink without actually seeing the image, and we will see the image later when we have the network streaming working. Okay, so I'm just going to save this, and this one needs to be at the top as well. In the meantime, while we are flashing, I want to also explain approximately what our application is going to be doing. Let's go to, do I have output directory now? Oh yeah, okay, so we see that semi-hosting is indeed working from app main, so maybe it's something related to the fact that I was calling it from the loop where we were processing the camera images. Maybe it has something to do with that. All right. So I think the fact that semi-hosting works is helpful. We just need to change the example a bit so that we don't save the image from the same task from which we are in which we are doing the processing right now. Before we get into the other part of the development, I want to try to explain approximately what our application will look like. So we have the USB camera. The USB camera is sending a stream of data, and that is in UVC. For UVC cameras, this is usually, there can be a bunch of different formats. It can be RAW formats. It can be, even for some cameras, H.264, although I haven't seen many such cameras. Most cameras can use MJPEG. So it sends frames which are encoded or compressed using MJPEG format. And we use the USB, we use the USB host UVC driver to get those frames. Then, well, we have MJPEG frames, and eventually what we want to do is we want to send them over the network using a protocol called RTSP. RTSP stands for Real-Time Streaming Protocol, and RTSP is one of the most common protocols that you will find nowadays within this IP camera market. It's an old protocol. I think there are some newer protocols now that are meant to replace it, but it's still very, very common. So eventually we want to send those frames to RTSP. And RTSP actually does allow transferring MJPEG frames, but it's not very efficient in terms of transferring them over network, because MJPEG compression only works within each frame. So it doesn't use the fact that the neighboring frames in the stream, they're similar. To use that similarity and to achieve better compression ratio, we have to use a codec such as H.264. So what we want to do is we want to take the MJPEG images, which are just JPEG frames, and decode them first.
Because for MJPEG, you have for each frame, you have a full frame, right? The interframe.
Yeah. Each frame is intercoded exactly. So we will decode JPEG, and we will get just the raw data of the frame in some kind of YUV format, and then we will encode that data to H.264. And these two things, like the decoding and the encoding, they will be hardware accelerated, because the ESP32P4 does have hardware acceleration for both JPEG and for H.264 encoding. And then the encoded frames, we can send them to the RTSP server, which is another thing that we will have to develop. And then the RTSP server will send the frames over the network to some kind of client. And in this case, we will just use a desktop application to connect to the RTSP camera. So that's overall plan for today. So we are right now somewhere here in the USB host UVC part. We got some frames. We just need to do a bit of more work to save those frames and so that we can see them. Then there will be this part that let's call that video processing. So we start with individual JPEG frames, and then we do some decoding, encoding, and then we get an H.264 stream, and then there is going to be the part with the RTSP server. I think we will try to do at least enough from each part in order to have the full working application in the end.
And talking about RTSP, we have a question. It is possible to receive and display an RTSP stream on ESP32P4 port?
Receive and display RTSP, yes, for sure. It should be possible. I think there is actually a component in the component registry. I saw it the other day. Let me bring that over here. There is a component for RTSP, and it's a client and server, you can use that for sure. And I think the only reason why we will not be using this component today is because this component only supports MJPEG streams, because it says that since ESP32 doesn't have hardware decoder for H.264, H.265. Now it does.
All right. So if it supports MJPEG, why don't we go directly from the MJPEG frames to the RTSP?
I think if we totally fail at the this image conversion part with us, that's what we will have to do. The reason is primarily just for network bandwidth. MJPEG is not a very efficient way to compress video, and for the same data rate, we will have much better quality with H.264, or vice versa. For the same quality, we can get much lower data rate or bit rate, and therefore network bandwidth with H.264. And right now, our board will be connected over Ethernet, so it kind of doesn't matter too much. I mean, how much bandwidth there is. But if we can switch to Wi-Fi connection, and we actually can switch to Wi-Fi connection because we also have ESP32C6 on this board, and later I will show how to switch the connection from Ethernet to Wi-Fi. In this case, it will help a lot if the stream is smaller. So that's why we are doing those intermediate steps.
Yeah, so for USB, it doesn't make that difference, but definitely for Wi-Fi, it will make a lot of difference.
Yes. So if someone wants to try MJPEG streaming, then I think this is your go-to solution, this RTSP component. But as I said, this component currently only supports MJPEG, and I think for that reason, we will not use it today. We will try to port a different library that wasn't written for ESP-IDF to ESP-IDF. Okay, so that's just a quick illustration of where we need to be. I wanna save just one frame actually, so that we have something to work with, because when we develop the other parts of this application, like this JPEG decoding and H.264 encoding, I wanna start doing this by reading one frame and then making it go through the pipeline, decoding and then encoding, and develop that as a self-contained piece of functionality, like a component. And then I will connect that to the rest of the application. So I need some sort of input. I don't want to be reading from USB host UVC all the time when I'm developing just this decoding and encoding part. So I will actually try to modify the example so that I can save the image, even though it didn't work on the first try. I think what we're going to do here is we actually already have that queue from which we receive the frames. So I wonder if I move this to the main task, it's going to work. It's going to work any better. So I think this one, this part of code I just don't need for now. Oh wait, no, maybe I still need, okay, the opening UVC device, that part I do need. So the only thing that I don't need is from here. So I'm just going to EBDF this part code out. And I'm going to move back to the main task. And over here, oh, I clicked the reformat code button, and I realized that I haven't actually set up the formatting in the project. So I like to be able to just reformat the code very quickly. But I didn't have the CLang format file set up yet. So I'm just going to add this CLang format file to my project as well. Or maybe I can find it somewhere else. Okay. Okay, so now I can format the code and it looks the way I want it to look. There is a frame queue we have created. Rx frame Q0. And this one is probably 0. And UVC stream, I guess I will need to save the stream somewhere into a variable in order to. Right. And this is the stream, so I will move that declaration to the top. And so UVC stream is going to be assigned here. And then I will wait for the frame and then just get one frame. And then I will save it. Okay. And then we'll do frame written. Let's give that a try.
Yeah, so semi-hosting is a great solution for what we are trying today, but as well could be used for different purposes as well, right? So that's another trick that you will learn today with us.
Yes, and I forgot when I disabled that code that actually that was a while loop. Okay, I'm modifying the example in kind of a quick and dirty way, so definitely don't take that as a recommendation of how you should structure your multi-threaded application. I just want to get a frame saved and so that we can move on to the next part.
Yeah, just to remember that this is our LED blink for today.
Yeah, it's taken quite long already, so we actually have to move.
But of course, it's a more complex LED blink.
Yes. And we did return from AVP main, but for some reason we didn't get the frame. And I'm not sure if it's because of the timeout. Maybe it just took a bit longer. So let's add a else here. And maybe I need something else from that piece of code that I have disabled. Ah, yeah, there was also UVC stream starts, of course. Now it should be probably fine. because OpenCD is not running this. Yeah, we're still getting this weird issue. Okay, I guess we'll have to accept that. It just doesn't work. It doesn't want to work today. It's a live stream after all. So we probably give up on saving the frame to the host, and we move on to the processing part. Yeah. I will just take a frame. We'll find some JPEG file, and then use that as our input. So to develop the processing part, let's. Okay, so I will create a new folder in the workspace, and that folder will be called, let's say, video processing, maybe. So that is going to be an application. Sorry, basic UVC stream video processing. So I'm going to add that folder again to my workspace. And then there is going to be, as usual, the main directory. I could have created this from the template. I'm not sure why I'm doing this manually. And this is going to be our application where we'll develop the video processing functionality. I'm going to copy the CMake list file from here. That's good. We'll need PSRAM, so I'm also going to add PSRAM component right from the start. I will create the new file, video processing main, and I will add over here in CMake lists. Okay, sorry, this should be. I've accidentally created the directory CMake list. My bad.
So just to make clear that you don't need to create everything manually, we have some tools that creates.
Yeah, there is a command create project from extension template, and I probably should have just used that. And I think this is enough for now. We will switch our workspace folder to that video processing, and as before, I will need to select the target, and that's going to be the P4, again with the USB JTAG. So now I need to find an image. I think I have some images here. Okay, get info. Okay, there I have some test image. So I will put the test image into the project. Sorry. Folder. It's going to be data, and into the data directory, I'm going to put the test JPEG file. I hope that I wanted to have that file to be the file that we actually capture from the camera, but I just took a capture that I had previously. And now we will write the application that takes that JPEG file and actually decodes the JPEG and then converts that into H.264. So we start with just creating some simple application boilerplate. I need to make that file available to ESP-IDF application. So in order for this, I think there is a command that I always have to look up in the documentation to add the I think you can actually add this with the IDF component register. Embed files, I believe, and that's going to be data test1 JPEG. I think it's something like that. And then the only question is going to be what's going to be the name of that data that will be added, but we will see that when we build the project. So we start off with the JPEG decoding, and for this I will need to use the ESP driver JPEG. And of course, I don't always remember all the APIs I have to use, so we will go to the documentation, the programming guide, find ESP32P4 here, API reference, JPEG encoder and decoder. Okay, so in order to add this component, I have to use this ESP driver, add ESP driver JPEG into my requirements. And therefore, I go back to the CMake list and I add ESP driver JPEG. And just like before, I will do the reconfigure. We will also need that include driver JPEG decode. Let's just see that this actually compiles. While it's compiling, I'm going to copy those two files related to CLang into the video processing directory as well. Okay, it did compile, so we have our file now, and now we will need to initialize the JPEG driver and to actually do the decoding process. I think there was an article somewhere on developer portal.
Yes,
is this right?
Yeah, we have a couple of articles at the developer portal, including this ESP new JPEG encoder and decoder. I will share the link right here on the chat. So we have one question. It's not directly related to what we are doing right now, but any tips to improve Copilot's RAG accuracy for specific ESP-IDF modules? Custom, for example, custom documentation sources, or how can we improve Copilot RAG for ESP-IDF modules?
That's a great question. I think that adding agents MD files helps a lot. The other thing that you notice that when I'm coding, sometimes it suggests like wrong header file names and wrong function declarations, or tries to use the wrong functions. There is something that we're working on that hasn't been released yet, and that is there are a few MCP servers that you can add to VS Code. One of the MCP servers that we actually have released already is the documentation chatbot MCP. So the MCP servers, they can help with when you're using agent mode and the Copilot is writing something, but it doesn't unfortunately help with those inline suggestions in the IDE. But we have a couple of solutions that we are prototyping now that might help us. So I think this is something that we may be able to improve. So I'm just going to verify that.
All right, so maybe that's a good opportunity to show how this chatbot works. So I like to share my screen, and then I can show you how you can go through the chatbot. Do you have my screen sharing? Yeah. So I'm here on the documentation.espressif.com, as known as CDP. And then here we'll see this icon that it's not only present at the CDP, but if you go, for example, to our documentation or even through our forum, so you will see this this icon right here. So if you click, you can ask questions not only in English but in any language, and this will be based on all our documentation, including datasheets, TRMs, programming guide, and everything that it is part of our documentation ecosystem. So, for example, we can ask, is there any JPEG decoder? Yeah, so, and then you will have the answer right here. For example, I can see all the documents that this answer came from. So not only you will see the brief description about what you're looking for, but as well the related sources. And you can, for example, go to the component right from the chatbot. I can also, for example, ask in any other language. Let's try, for example, Portuguese. So let's try in Portuguese. And yes, we'll get the answer in Portuguese. So no matter the language, you will get the answer. This helps a lot. And many people are using this solution as the first resource or the first search. Instead of you going to the regular search, you go through the chatbot. So please test it, use it. It is for free, and we'll be happy to get feedback about the chatbot as well. All right. So,
okay, so we are back here. So I've written some code that initializes the JPEG decoder. And just one thing that I'm checking is the image resolution that I'm going to be working with. So I have just the image that I had initially was 1080p, and just for the sake of developing this part, I've downscaled it to 720p. So in the actual application, I will know the resolution up front. Here, I'm just having to hard-code it. Essentially, what we need to do is we need to configure the JPEG decoder. There is some this is the configuration for the JPEG decoder itself. This is the configuration for how we are allocating the memory for the output buffer of the JPEG decoder. We will also, I think we will also allocate the input buffer for the JPEG decoder. Even though the data of the JPEG frame is already in memory, but it's going to be stored in flash memory in this test application because I'm adding the JPEG as part of the program, and it might not be aligned to the 16-byte boundary that the hardware wants it to be aligned for efficiency. So I will actually allocate both the input buffer and the output buffer. Okay, so I have the memory allocation done. Now we have the JPEG decoder memcg. Okay, and now we have to copy the image into the input buffer. This is the where we are copying. This is our image that we got from the binary file, and then we get to the actual decoding part. So I'm just looking to the documentation on the side of the screen for the actual invocation of JPEG encoding or JPEG decoding. Sorry. So I will need this structure. I will explain the format, the output format in a second. RGB order is, it doesn't matter in this case. Deck. SGB should work. And conversion standard is the one that I'm just going to copy. So this is basically the configuration of how we are doing the decoding. And then we need to call the function JPEG decoder process. And it takes the handle that we previously got, JPEG decoder engine. It takes the configuration that we just made. The input data, the size of the input data, the output data, the size of the output buffer, and then the output size. So we also need to declare okay, and we put an ESP error check around this so that we can know if something fails. Compiler is helpfully asking me to free the buffers. I'm not going to free them just yet. So that is our decoding code. It involves initialization of the JPEG decoder and then allocating some memory, copying the data, and then actually doing the decoding. So let's try to build that. JPEG decoder process. JPEG decoder process wants the output size to be a unitary 2. Okay. And there was also an unused variable somewhere. Okay, that built fine, so we can try to run it. And I have to set the port again. And now we can run it. Okay, so now I get an error during flashing that there is a mismatch of the chip revision. And as I said, I'm using an older revision of the chip. So it's time to go to menu config and actually ask to use the older chip revision. And this is done by this option. So most people will, I hope that before mass production scales up, most people will be using the new chip revision, so older than 3.0, and the default will work for that. So I'm saving that and building and running again.
All right, in the meanwhile, we have a question here. Is there any ESP32P4 chip plan that natively supports networking? I don't know, ESP32PX. So ESP32P4 does support networking. We have Ethernet. We don't have the fee. You still need the fee as you usually need for example, for the ESP32. We don't support wireless networking, but we do support cabled networking. But you can use, for example, in this case, we have the C6. So you can use, for example, an ESP32 C6 or eventually the C5. And then you can add wireless connectivity. But you have Ethernet, and we will actually use it here. If we get to the point, to this point, we will show Ethernet working on the P4.
Okay, so the example now is crashing. Let me try again. It's very weird that. Oh wait, I'm still running the. Am I still running the basic UVC stream? Wait a second. Workspace folder, video processing. Maybe I was running different apps already.
I think you're on the other workspace.
Yeah. That's very weird. I'm in the video processing. Am I running the different application? That's quite odd. To run into a breakpoint, which is weird because I haven't even initialized semi-hosting in this case, and that looks a bit surprising. I'm just going to remove everything from the application to make sure that
let's do it.
We just do the sanity check. Okay, so that works. All right. Let me just check if I'm doing any obvious mistake here. I am not actually setting the sizes. Okay, that's one of the things that is probably wrong. And then I'm using those sizes. So now the input buffer for JPEG, actually I'm allocating it same as the output buffer. It doesn't have to be that big because it's going to be smaller, but this is just for this toy example. We will eventually get the input buffer coming from the UVC driver. So that's just a simple way to do this. And here I can reuse that variable for output size. There I can reuse the input buffer size. And JPEG decode. Let's just add return on false. Let's just add memory allocation checks. ESP return on false. And ESP return. We are in a function that doesn't return an error code, so we need to use ESP return void on false. Okay, so it tells us that it failed to allocate the decode output buffer. And I think I probably know the reason. We are trying to allocate a very large buffer. A 720p image probably needs like a 1 megabyte or something buffer. But we don't have that much internal memory, and I actually didn't go into menu config to enable PSRAM, so that's my mistake. We can go and search for PSRAM, support external PSRAM. Okay, it's configured. It's 200 megahertz speed, so we should be good. While we are here, I will check the CPU frequency, 360. I think that's what my board here, the mass production boards will do 400 megahertz. This board only does 360. So we close the SDK config editor. And now we try again. This time, hopefully, we will have the SRAM actually initialized, and there will be enough memory to do the allocation.
Yeah, so I see that the chat here on YouTube is not that active, so please ask questions, do comments, or leave feedback. So we are really looking forward to hear you from the other side.
Yes. Now we have, okay, so now we've got to the point where the JPEG decoder has been created, but we are getting an error message that detected YUV40, but we want to convert to YUV422, which is not supported. I'm not sure we have to go very deep into this, into the difference between different YUV formats, but essentially YUV422 has for every 2 pixels of the image, it has 2 brightness components, but it has only 1 pair of color components. And in YUV420, it's for 4 pixels. There are 4 brightness components, like 4 brightness values, but only 1 pair of color values. And what the decoder is telling us is that I have asked it to provide the output image in YUV422 format, but the input is actually YUV420. So yeah, I will change the format from 420 to 422. This is the parameter over here.
And just to give a little bit of context about what is YUV, is a way you can reduce the image size with a minimal loss. So as Ivan said, I don't think we need to go into the details, but this is one of the ways, or actually we'll need it in the future, especially for the 8 to 64. So we need to do this conversion before moving forward.
Okay, so the application ran this time. There are no errors reported. The conversion was done. Again, we don't see the results. So maybe we give it one more try, and maybe we try to enable semi-hosting once again, so that we can actually see the image. And over here include SPVFS semi-host. And over here we register semi-hosting, and over here we do output decoded image YUV. Okay, so that looks about right. Sorry. It's complaining something about F-write. Did we? Yeah. I don't actually have the output folder. That's true. Maybe I can store it in data. It's just going to be data. Close doesn't need that. Okay. Yeah, we're definitely not having a lot of luck today with OpenOCD. What if I actually put a breakpoint here and just run the application? Sorry, I didn't add. Yeah, for some reason, semi-hosting today just doesn't want to cooperate. That's very unfortunate.
It was something we would like to show, but it's not going to happen today.
Yeah, it is what it is. We will just have to. We will just have to try something different. Yep. No way. Okay. All right. So
one thing we can do is we can publish later on an article on the developer portal on how to use central hosting.
yeah, we will make sure that it actually works well in this case. Okay, so we have decoded the JPEG image. We're having trouble saving it to the computer, but I think we can still go ahead and we can do the next step, which would be to add the H.264 encoder, because that part we can still do that. Are there any plans to add dedicated AI/ML hardware acceleration on future ESP32 chips? Yes, definitely, there are such plans. Even on the P4, you have the instruction extensions like vector instructions that can accelerate some operations quite a lot. Yesterday, we had a talk on ESP detection, right? And from that talk, you can see roughly what kind of performance you can get on ESP chips. Is kind of enough to do some object detection or person detection for a low resolution video. But we're definitely looking at having more capabilities in future chips. All right, so we move on to the ESP-H.264. Again, I'm going to open the component registry. And there is this component, Espressif ESP-H.264. This is essentially the driver for the H.264 encoder we have in the ESP32P4 chip. So I need to add that component to the project. The dependency has been added. And we have, okay, let me remove all the boilerplate. We have the ESP-H.264 component now. I will run reconfigure again so that we actually fetch that component. And next, so we see that we have the managed component directory, and in the managed components, there is the Espressif ESP-H.264 folder. So we can go and start using the H.264. Now with H.264 again, we will have to initialize the decoder. And this is very similar. So I think we need to allocate the input buffer. In this case, right now, the JPEG output buffer is the same as H.264 input buffer. So I'm only going to declare a variable H.264, sorry, not 5.
Yet, yes, input buffer, and we will also have the H.264 output buffer. So for now, the H.264 input, not input. H.264 input buffer will be just equal to the JPEG decode buffer. Later, if we need to split them and we need to have them run in parallel, for example, we will allocate it as a separate buffer. H.264 input buffer will go in, we can basically just say that once we finish the decoding process, okay, let me remove the semi-hosting part. This doesn't seem to be working anyway. H.264 input buffer is essentially just JPEG decode out buffer, and H.264 input buffer size is JPEG decoded output buffer size. Next, we need to allocate the H.264 output buffer, and we can use the heap caps malloc for that. The H.264 output buffer size, so it's definitely going to be less than the size of the image. How much less it's going to be, it's going to depend on the bit rate that we pass to the H.264 encoder. But usually it's safe to say that it's going to be at least like 10 times less than the original image. So given that the original image, let's say it was width times height
times 2 bytes per pixel. So we can divide by 5, and that's going to be kind of a reasonable estimate, I think, for the size of the output buffer we will need. And we want to put this buffer into SPI RAM, and we also want to make this buffer cache aligned. So now we have the buffer. We need to allocate we need to create the actual encoder. And we do this first of all by including ESP-8264. Let's see if that's the right. Yeah, that's not the right one. The actual header file is called ESP-8264 enc. Single software, and also just in case ESP-8264 types. Okay, so we need the ESP-8264 encoder. It's going to be the handle. And we need to call a function to actually allocate that encoder. I'm just looking at the name of the function we have to call. So it's going to be this function that we use to. We also need the configuration for the H.264 encoder. And so we'll fill this in a second. H.264 encoder, and we will of course do the ESP error check on that. Sure, why it's complaining about the ESP-8264 encoder hardware T not being found. Did I include the right file? Oh yeah, because I included the software one. I need the hardware one. Okay, now it should be better. Yes. So this one here, we have to specify a few things. So we have to specify the target frame rate. Let's say I would say 15 frames per second. The GOP is effectively the interval at which the keyframes are. So I will set it again to the same frame rate. So it's going to be like 1 keyframe per second. The picture type. What is the picture type, I wonder? Okay, there is the resolution and RC parameter. Okay, so there is the resolution. And the resolution is given by the width, which is, in this case, that part is pretty clear. And then we have the rate control. That's what the RC stands for. And in the rate control, we have to specify the bit rate. And I will just say 100 kbps for now. And we have to specify the range of QP parameters. QP stands for quality parameter, and essentially the lower web values of QP in H.264 is higher quality, the higher values is lower quality. So just a ballpark, I think 20 is reason 20, and the maximum one, let's say 30, is going to give us a reasonable range of quality. Okay, we have the configuration for the H.264, and now we have the H.264 encoder created. And that is not true. we also need to declare a structure called H.264 enc output frame. And the input frame, we have to set raw data. I think it's something like this. Buffer is this, and length is that. So H.264 driver accepts accepts the input frames and output frames as those kind of structures. This is the input frame, output frame, and now H.264 encoder process. So we have the encoder, we have input frame, we have output frame, and I think that's pretty much it. Output frame, length.
It's worth mentioning that we have a practical usage guide on the developer portal, so I will share the link here in the chat. So if you're curious about how it works and if you're as well trying to use it, I will give the link to the article.
Yes, so I'm getting an error that we haven't set the pick type parameter for the H.264 encoder, and we'll go back to the configuration and just check what that parameter is. It's in the encoder config, and this is essentially the format. So we will have to use this format, I believe. Yep. So over here we add pick type. H.264 created, and we get assertion failed. Let's wait. How far did we get? The JPEG decoder was created. We did the JPEG decoded output, and we apparently did manage to allocate the output buffer for H.264. We have created the H.264 encoder, and then we failed somewhere on H.264 encoder process. Okay, let me confirm. Looking again at the example code of H.264. What else do we have to do? H26 encoder created. It's also weird that I'm not getting actually the serial output from the panic handler. Let me try to change that, because I'm only getting the assert, but I'm not actually getting any backtrace. I'm still getting any backtrace. That's really weird. What might be happening, though, that I'm thinking, that I'm not actually sure how much stack space the H.264 encoder need, and maybe that's a substantial amount. So just to make sure that it's not something related to this stack size, because I'm still running inside ITP main, so we are kind of on the main task, so I will bump up this to, let's say, 8 kilobytes, and then we can try to run it again. Maybe that was the problem.
So it's been like almost like 2 hours we are here, so we might need some coffee.
Yes, we can take a short break, and then we will come back and continue working on our test application.
All right. So let's say that we will be back in 15 minutes.
Yeah, looks good.
All right. So let's take a short break. We need some coffee, and as well, you also need some coffee or some other drink. And we'll be back in 15 minutes. And yeah. So, see you. All right, so we are back a little bit before the planet because we have coffee here, and as you know, cough in, code out, and we have a jar here.
We are ready for some rubber duck debugging.
Yeah, so now we have some help here, so I will leave the rubber duck right here, and then
we can go into our debugging session. So right before the break, what we got to was that we wrote the code that should do H.264 encoding, JPEG decoding, and H.264 encoding, but that code kept crashing, and in the panic output that we saw, I'm just going to make it a bit bigger. What seemed to be happening was that there you have this kind of assert failed and queue semaphore take, and that usually means that if we are asserting on a queue, and it means that the queue was null. So it's like somewhere some code called a semaphore take, like usually like a mutex or a semaphore, on a null pointer. So we have something that's not initialized essentially. So we have to figure out what. And the place where it happened was that that code in the H.264 encoder. So you see that there is this line which says H.264 mutex lock, and it's the frame down is the mutex that it's trying to lock. So now I've started the debugging session, and I've actually already got to the point right before this, and I see that this in the hardware handle over here, the frame done is actually null. So it's not initialized. So we just have to find out why it's not initialized. Either I'm not initializing something properly, or there is some other reason. So in order to find this out, I'm going to set a breakpoint to the point where we are actually initializing that mutex. And here I'm definitely doing something that I wasn't expecting to do during the live stream, which is debugging a driver. And it's not something that I hope that most developers have to do, but I think it's a useful thing to go through. I'm just trying to find where this is initialized. Okay, so this is where it's initialized. And I'm just going to start debugging again. Oh, okay, so the initialization function never got called. That's probably the reason. Why did it not ever get called? So it should be called, okay, because I'm not calling the encoder open. Apparently there is another step that I'm missing in the process. Okay, so it was not as bad as I thought. Yes, even Copilot suggests that I add this ESP H.264 encoder open, and that's apparently where the semaphore gets allocated. So I think now it should hopefully work. Sorry. Yay, it worked. So we now see that the H.264 has encoder has produced an output of certain size. That's like a frame. The H.264, the output of the H.264 encoder actually will contain a bunch of packets, but the biggest of them will be that intracoded frame in this case, because we only have one frame. Okay, so we got show us in Rust also. Okay, that's going to be the topic of next slide. We have to do this, right? We have to do the same thing in Rust. Okay, at least we got this step working, which I'm very happy about. We will now move on to the next part. so far, as you've seen, that we are only encoding one frame, right? So I took a single JPEG, and essentially I just have this part as a separate application, the decode JPEG and then encode H.264. But we have something that goes out of it, so there is some H.264 output. Now I want to move on to the RTSP server, because I think it's also going to be a kind of an instructive part. And then hopefully we still have time to put everything together, the UVC, the decoding, encoding, and the RTSP server. And then we'll see how quickly we manage to do this. Maybe we hang around on the stream a bit longer than we expected, but
we have coffee.
We have coffee.
We are good.
If there's going to be someone who's going to be following us, then we are happy. Okay, so now we will move on to the part about RTSP. And for RTSP, I found this library. The library wasn't written for ESP chips. It was written, it's actually part of a community called OpenIBC. OpenIBC develops alternative firmwares for IP cameras, for Linux-based IP cameras. So since our camera is not a Linux-based camera, we have a microcontroller, we can't use that OpenIBC, but in that OpenIBC community, there is a project called Small RTSP, and it's, as the name implies, a small RTSP server that can run on Linux. And what I will try to do now is I will take this project that was written for Linux and try to run it as part of an ESP-IDF application. So again, we will need to set up a project first. Where's my VS Code cursor? Sorry. Okay. We will need to set up a project. I'm going back to the workspace, and I will create yet another directory here. I will call it RTSP server. I'm going to add the RTSP server to the workspace. And over in the RTSP server, actually, let me use the built-in functionality in VS Code extension to create the project this time around, so I don't have to do it myself. Let's delete this for now. RTSP server delete, and now I want to use the function in the extension to create a project from extension template. I will create it inside this directory, and I will just use a template app here. Okay, I'm going to close this. So we have a template app created. I'm going to rename it to RTSP server. I'm going to add it back here. We will not need the dev container. We do need the VS Code folder. We do need the main. Here I'm also going to change the name to RTSP server, switch to more recent CMake, and limit the build to just the main ESP, PSRAM, and everything they depend upon. Then we will choose this RTSP server as our workspace, and we will create. We already have VS Code configuration files, so that's good. We don't need to do that. One more thing is I want to copy those CLang format files into RTSP server, and just to make it quicker, I will copy my SDK config as well, so that I don't have to configure this project. So now the RTSP server will be also configured with PSRAM enabled and all the other changes that we made. Let me rename this to RTSP main, and over in CMake list also rename it to RTSP main. We have the template set up right now. I can select target, going to be P4. And I will select the port as well. Okay, so we are all set. We can build it just to make sure that everything's fine. And now we are ready to add that RTSP component. Let's go to this repository, and I will clone this repository. I could add it as a submodule, but for a reason I'll show later, I will not do this yet. I will just clone it as a project. Inside RTSP server, let's create the components folder. And inside the components, there's going to be, let's call it small RTSP. This is going to be an IDF component that wraps around the upstream library. Here we'll have a CMake list file that for now we will just keep empty. And
again, you can do it with the create component comment.
Yes, right. There is a create component comment. We could have used that as well.
For today, we will use the manual way, but there is a shortcut that you can use.
Okay, so now I want to clone that project into the small RTSP directory. So we get this directory now with the component. It has its own CMake list file, and like I picked a library that does come with a CMake list file, so that I don't actually have to create a CMake list file for it. So it should be relatively straightforward to add that library. It's not always like that, but I think this library is kind of written in order to be easily addable to other CMake projects. So I think it should be enough to just do add subdirectory. This effectively tells CMake that there is a subdirectory that contains a CMake list file, and you can just go inside the directory and add whatever is defined by that subdirectory. And I think that CMake list file inside smaller RTSP directory will define a target that we'll have to link to. So essentially, it will build a static library. You see that it has a property small RTSP shared, build shared library. That's off by default. We don't want a shared library, we want a static library. It also will download some of its dependencies. So it's a small RTSP depends on slice 99, metalang 99, interface 99, so some other libraries from the same author, I guess. And then it defines its sources, and it does this add library, right? And the add library defines something with the name of library is the same as the project name, and the project was small RTSP. So there should in fact be a small RTSP library. So we should be able to do target link library exactly like this. And then let's go back to main. Let's go back to the main CMake list file, and here we add a small RTSP component as a requirement of main. So now that's the first kind of dry run, or let's try to build it and see what happens.
It's not as easy as installing or adding a component from the registry, for example, but it's not that hard as well.
It's not that hard. Okay, interface library can only be used with interface keyword. Okay, fine. That is because in the small RTSP wrapper component, I actually haven't added any source files, so it wants me to make this library also interface library. I will actually need a source file later, so I'm actually going to create one right now inside the small RTSP component. RTSP server.c, and it's going to be empty for the time being, but here I will specify this file. Let's try it again. Okay, so now we get some first issues during the compilation. So we see that small RTSP source code wants to use syssocket.h. In ESP-IDF, this file is provided by LWIP component. So we need to make sure that the library actually has access to LWIP component. And we can do this by saying that the small RTSP library will have a dependency on some IDF components. And we need definitely LWIP. I think we may need maybe newlib, and let's add, I'm not sure we'll use anything from VFS. Probably not. I think it's just LWIP and newlib should be enough. Let's try to build again. Okay, so now we have the next error. Okay, so that the library actually doesn't exist because I haven't added it as a dependency to any of the components. So I'm also going to add that requirement so that the build system knows that we actually need to build the LWIP library. This part is something that I mentioned in the keynote, that we have a technical preview of our new build system in IDF 6.0. And this is one of the areas where it should get a lot easier in the new build system, because generally the component dependency management becomes a lot simpler.
So this is one of the breaking changes for the IDF 6.
And then it says that IDF newlib is not found. No, actually, the new build system is not a breaking change, because we're still keeping the old build system for now in place, and all projects that use the old build system, they will keep working subject to all the other breaking changes that we're making. The new build system is opt-in, so you actually have to write your project CMake file slightly differently to tell us that I actually want to use the new build system. So that one, and we have designed it in a way that most of the components that have been written for ESP-IDF that we have published in the component registry, or someone else has published in the component registry, they will keep working in the new build system as well, and people will not have to rewrite them. Projects may require adaptation, but generally it shouldn't be too bad. Here I'm actually running into one of the breaking changes in IDF 6.0 is that we used to have a newlib component in IDF, and now it's called ESP-libc, because we now have we support two C library implementations, newlib and picolibc. So in order to not call the component responsible for picolibc newlib, we just renamed it to ESP-libc. So let's try to build again and see what happens next. Okay, we went through the CMake phase, so now we are actually compiling some files. That's good. And we get the next batch of errors. Apparently there is some code inside small RTSP that triggers a compiler warning, which in our case is the error. I will trust small RTSP authors that the library actually is functional, so I will say that I will ignore this warning. Therefore, I will do target compile options, small RTSP, and I will say that no subscripts. Basically, I'm just saying don't warn about this just when building this library. For the rest of the IDF, it still will warn about that. And we run into the next step, or the next problem. Now, the udp.c file inside small RTSP is trying to call setSockOpt, which is setting an option on a socket, and it's specifying an option name that I'm guessing this is something that only is available on Linux. Yes, this is a Linux socket option. So we don't have that. I'm not sure if the code will break. Usually options like this, I think this is something related to MTU discovery. If you simply just don't set it, I think it will be fine as well. So I will just say that this code should only run if that option actually is defined somewhere. And let's try to build it again. And we get to the next error, which is that in RTSP transport, we're calling H2BE32 function. And I think we need to include ndn.h as the copilot suggests. So let's try to build again.
Okay,
and build.
Yeah.
Okay. Well, I mean, there is not much to flash now because we actually haven't called any useful code, and yeah, we still have that problem that we will need to change the chip revision in menu config. We are using null chip revision, and just to check that whether I have PSRAM. No, I don't have PSRAM enabled. Okay, now I do have PSRAM enabled. And let me switch to console USB serial JPEG as well. So I think that's all. Those are all the changes that I need. Okay, so to summarize what we've done so far, we actually managed to take that library and build it with just 2 modifications. I think it's pretty good. Usually, if you're porting something non-trivial, then you have to do more changes. Here, it was kind of simple. So next, we can continue integrating this library into our application. One thing that I want to show is, because I've essentially taken that small RTSP library and cloned it inside that component. So now I have my component, which essentially contains just the CMake list file and the RTSP server file, which is so far empty, and that subdirectory, which is now modified from the upstream version. So how do I, if I want to share this component somewhere, even push it to the Git repository, what do I do with it?
Patch.
Yeah, we'll have to patch it, yeah. And actually, CMake does have functionality for that. I don't have to take this small RTSP library and bundle it, like what's called vendor it, right? So add the source code into the project. I can just ask CMake to download that library from GitHub when the project has been built and patch it in place. Now, you may decide to do this or not. Like, for example, if you are developing an application and you don't have internet connection sometimes, then maybe you don't want to do that, and you actually want to add that library as a submodule. If you will be doing more extensive changes or you will be frequently upgrading the library, maybe you want to use a submodule. But in this case, I don't anticipate upgrading the library so far, for now, at least during our session. So I will do it kind of the CMake way, and I will use the fetch content module of CMake. See, it's even guessing the name of the project, which is actually not the right one. No. I will change it to the right URL. And as for the Git tag, let me go into the terminal. This is the Git tag we are on. So this is what we are going to be getting. And we also need to patch this. If I run git diff in that small RTSP project, you see that these are the changes that I made. So I will commit those changes. Right now, I'm just inside the small RTSP copy that I have cloned. So I'm going to git add everything. I have those 2 files. I will commit and say that ESP-IDF compatibility. And then I will create a patch file out of that. So that gave me a file that I will show you right now. This is a patch file, and it contains basically my changes. So now the only thing I have to add to my project is to add this patch file. So I'll move it one level up into the component. And now I'm ready to actually just completely delete this directory. I will not need it anymore. I will not need it because now we will download this directory, this repository using CMake fetch content. And the only thing I need to, as Copilot suggests almost correctly, is I need to do this. I need to specify where the patch file is. Yeah. ESP-IDF compat patch is the name, right? Yeah, it's right. I think that patching during fetch content is kind of tricky because CMake doesn't know if the directory that has been downloaded has been already patched or not. So if you run the build 2 times, it needs to know not to do this. Or, which is simpler, is actually yeah, I guess it will work. So essentially, I'm telling Git to first check out that version. I think there is probably a nicer way to do this than copying this hash in 2 places, but it doesn't matter too much for now. And then I will run that git apply command to.
In this way, we are sure that we're now applying the same patch twice.
Exactly, because that will likely fail. So now let's try to actually build it. So this time the build should take longer because we will be again downloading, like cloning that repository. Okay, we got an error. Apps which is not an existing subdirectory. Yeah, okay, so I need to remove now that add subdirectory because I don't have the subdirectory anymore. And we will not need this because the fetch content make available will actually call the add subdirectory for us. No, it's actually compiling. So it has apparently successfully downloaded the project, patched it, and now we kind of have very clean, I would say, setup where the small RTSP component just contains the CMake list file, which is simple enough, and it has that patch file where we have all the changes necessary for compatibility. All right, we got to add that small RTSP to the project. Now there is the other part, which is we actually have to use the small RTSP. And if we look at small RTSP, which, by the way, now it's the only thing is that now it's in a very inconvenient place. We have to go to the build directory. We have to go to, I think it's in CMake files. I'm not sure. ESP-IDF. I have in video processing, yes. I have to go to build directory. There is the deps folder, and here's all the dependencies that CMake has downloaded. So there is the small RTSP SRC, and inside there is actually an example. So they have an example for our small RTSP. The example, if we can go to the very end, it's quite a substantial one. Like it's 700 lines of code, and actually most of this code is necessary in order for the example to work, because what happens is that even though the library implements the protocol, the behavior of the server is written inside that example. Unfortunately for us, the way the example is written is that it uses a library called libevent, and this is a Linux library that's used for synchronous networking and event handling. So we will not be able to use that example as is in ESP-IDF. Most of the code here actually is not dependent on that libevent. It's just that working with the network, so you see that their libevent provides some utilities for socket communication and also for timeouts. That part depends on libevent. Otherwise, the example is actually portable. It can be ported to ESP-IDF. What we will do now, I think we could do it 2 ways. So one way is that we actually go through the porting process. The other way, which I'm inclined to do right now, given that we've kind of already used quite a lot of time, and I want us to eventually get to the final application. I have done this port of the server example to ESP-IDF a few days before, just to make sure that it's actually going to work. So I will kind of cheat here, and I will not live code this part. So I will just pull out the file that I already wrote for this purpose, and then hopefully it will help us speed up the process a bit and get faster to our final goal. So this is the RTSP server file, and I'm just going to take the code that I've developed previously, and I'll walk you through the code a bit. I also need to have the include file. So let's create an include directory. And over here we need the RTSP server.h. So essentially, what I'm doing is I'm wrapping that whole functionality, meaning the small RTSP library plus that server, which we took from the example, into a very, very simple API that can be used in the application. So the API essentially consists of the configuration structure that defines things such as on which port the server should be listening, some parameters for the stack size, and a bunch of callbacks that will call back into the application. And the server API only is to start the server and then to send a frame. That's all there is to it.
All right, so this will be the because RTSP also supports some more, for example, like control commands like play, pause, stop.
Yes.
But right now we are just using the streaming part.
Yes, and I will also add the include directory into the CMake list. Let's go and try to build that. If we look at this RTSP server C file, actually a lot of things in it, they are the same as in the original in the original example. Most of the things that I had to do here, I had to create this client task, like FreeRTOS task, that actually uses standard BSD socket APIs to receive data from socket and feed it into the RTSP server. That's pretty much all there is to it. There is like these functions, for example, they are exactly the same as in the original RTSP server example, and most of this porting was successfully done by Copilot or Cursor in my case. So it's not a terribly complex process, just it still takes a bit of time. Let's see how it went. I think we built successfully. So we don't have anything working yet because, of course, in the main application, we haven't called the new RTSP server component. So let's go to main. We already have the dependency on the RTSP server, so we will include RTSP server. And we also need networking connectivity. This is where we get to the Ethernet cable. Yeah. So we will need to connect to networking. I will do this in the simplest way possible that we have right now, which is to use part of ESP-IDF that is called protocol examples common. So IDF has a bunch of protocol-related examples for HTTP servers, clients, and so on. And to avoid adding a lot of boilerplate to those examples related to network connection, we have this component that's part of ESP-IDF. I will reuse this component right now to just quickly get connected to network with one function call, or 4 function calls. I will need to add some dependencies. So first of all, I will need to add components such as ESP netif, ESP event, and I think that, and maybe NVS flash as well. In RTSP main, yeah, and I will also need to add dependency on that component inside ESP-IDF. And to do that, I will create an IDF component YAML file. You might ask, why am I creating IDF component YAML file? And I'm going to use ESP-IDF component, right? So ESP-IDF component YAML file actually can also be used to add dependencies on components, not only from component registry, but from local folders and from Git repositories. So this is the functionality I'm using right now. This is what we're going to do. So we're essentially saying that this component depends on a component located over here inside ESP-IDF. The reason why I'm doing this in the IDF component YAML file instead of the other option to add this directory to extra component dirs in project CMake list file is because I think this is more expressive that this main component specifically depends on that protocol examples common and not just the whole application. So that's why I prefer to do this in this IDF component YAML file. So we added this, and we have added the dependencies. I will run the reconfigure command again so that the IDE can pick up the changes that we have added dependencies. So now I can include ESP netif, ESP event, and NVS flash, and also protocol examples common. This is not needed. And over here we do ESPR check example connect. It has generated the boilerplate for starting the RTSP server. I think we're not quite ready to start it yet. We still need the callbacks, but let's just get the network connection going first. And at this point, I also already need the Ethernet cable. Okay, so we see that APP main ran, and we got the IP address. So that's our Ethernet connection. Now, how does it know that it has to connect over Ethernet? Well, there is a menu config menu. Let me open the configuration editor. Build settings. I think this is an issue that's fixed in it's going to be fixed in the next VS Code extension release. Right now, you see I've added a new component, but I don't see the menu of this component here yet, and I will actually have to. There is a command here that I'm going to use, and I will run menu config again. This is something that we noticed recently, and we'll fix it. So now we actually should have Ethernet configuration and example connection configuration over here. So in the example connection configuration, you see I have this checkbox, connect using Ethernet interface. There is also PPP interface. I don't have Wi-Fi. On chips with built-in Wi-Fi, you would have that checkbox. But later I will show that how we can add a component called ESP Wi-Fi remote that will enable that transparent connection to Wi-Fi through ESP32C6.
And then you can switch easily.
Exactly, and there is just going to be one more checkbox, connect using Wi-Fi, and we can enter Wi-Fi credentials there. So for now, we'll keep it on Ethernet. I will close that, and this part essentially works. So we actually can enable the RTSP server right now. Let me give it a bigger task size because I think it's a library written for Linux, so usually it might require a bit more task. Well, thankfully, P4 has quite a lot of RAM to handle that. And here is, you see, Compiler is already suggesting me that I should define those callbacks. So that's going to be the next thing that we're going to do.
So now it's time to put some glue on our code.
Yes. These callbacks will be called by the RTSP server when the clients are connecting or disconnecting. We pretty much just log some stuff here, and we don't actually need to do a lot just yet. I also need to include ESP log and define define the tag. So when we get the callback to start the streaming, I will need to somehow start actually sending the frames. So for this, I will create a task. And I will inform that task. So let me just create a semaphore here. I will need to include FreeRTOS headers. It's not the best way to do it, probably, because we will also have to handle disconnections at some point. But just to will you share the code after completing it? Yes, for sure. I will share the code after completing it. Yeah. So either we complete it today during the live, or I will, like, once we finish, I will complete the parts that don't work yet, and I will push it there. So let us just wait for that semaphore.
So at the end, we can go through a recap and walk through the, not like line by line, but we can walk through to the final code.
Okay. When the client gets connected, we need to save this client context somewhere. So I'm going to create another static variable for that. And we also need to have the frame, where we get the frame yet from, well, we can take it from the, we can add the code that we had in the basic UVC stream example, I guess.
Because right now we have the static image.
We have the static image, but it still will produce, it still will produce the H.264 stream, right? So if we test this without adding the UVC camera first,
yeah,
then that's probably going to be the easiest way to do this. Sending the frame, what else do I need to do? I need to give the semaphore when the client is on start streaming. So here I save the client context. Let's call that as client context. And as connected sem. We need to create the semaphore. And over here, we give the semaphore. This is as connected sem as client context. I also need to have the frame, the actual frame data, frame sent length. Okay, so this is going to be what variable type it is, size t, right? So frame send length, timestamp. We will just get from ESP timer, which we also will have to add as a dependency. And that's almost it, except that we don't have the frame and frame length yet. So I'm thinking whether I will just add the code I have from the video processing project, because I was making shortcuts, and this is something that you shouldn't do when developing a real application. I was not arranging the code as components properly, and this is why now part of my code is in one project, part is in the other project, and part is in RTSP server. So there is definitely a moment of reckoning, and when you actually have to sit down and rearrange everything properly as components.
Yeah, but for the sake of time, we are allowed to do that today.
Yeah, we have to do this. So I will. Let me see. Maybe I can also add the H.264 frame just as a binary set, same as we did before. I think that's probably going to be the easiest. And then once that part works, like once we have the RTSP stream working, then we combine everything together.
Yeah.
Okay, that's the plan. Let me add ESP timer here as well. And let me add embed files frame.h264. Say input.h264. Actually, let me see. I think maybe that project, the RTSP, server, sorry, the small RTSP project actually has some h264 file, input file, like inside the example. So maybe I will just use that. Media, it does have. I will just take that, and I will use that for the sake of making it quick. So I will put it just into the main. And this is my video.h264. And I will make it video.h264. So now that h264 file, I'm not sure how big it is, but it's going to be embedded into the binary. And then we will be able to reference it just like in the video processing project. We will reference in the input JPEG image. So I'm just going to copy this part over here. A video h264 start, binary video h264 start, binary video h264 end. Okay, that's it. Oh yeah, and over here, basically the same. The frame is this, and this is our h264 video. Sure, let's complain about. I think that it could work. I'm not sure it will work, but it could work. One thing that I'm kind of concerned about here is that video from the example actually contains multiple frames. And I'm not sure I'm allowed to call RTSP service send with that entire huge chunk of data. Maybe I will actually need to split it into frames.
I see.
But we will see this now. Okay, says RTSP service started on port 554. I have VLC player that I'm going to use.
So we'll publish the RTSP URL for the session. Unfortunately, no.
Yeah, I think it's going to be a bit difficult because it's in my. I actually am not even in the office network right now, so I'm connected to like a separate router. But it's a cool idea.
Yeah,
we could definitely stress test the hell out of the system this way. Okay, so there was some activity here, but then nothing happened. I think I'm not managing to start sending the frames for some reason. Let me take a look at the log once again. So service started, streaming started, and then nothing. Let's go to main. I think this never happened. Sending frames. Streaming started. I'm giving the semaphore. Because yeah, sure. I haven't actually created a task.
The task.
So I need to go here, and before. It might be fine. Okay, and now we have a problem because it says that the factory partition is too big to fit. So, but the default size is 1 megabyte, and it overflowed by another, let's say, 600 kilobytes. I think we could create the partitions file for that. RTSP server. Am I in RTSP server? Yes, I'm in RTSP server. And again, here I'm forgetting to use the features that we have in the VS Code, because we do have the partition table editor. But again, because I'm a bit stressed out that we are moving slower than I wanted to move, I will just find some partitions file that I can reuse. Okay, it should work. So our factory partition is going to be, let's make it 2 megabytes. Sorry, 2 megabytes. And we don't need this. And I need to go to menu config to actually make sure that I have enabled the custom partition table.
And maybe another question that people might ask. So you're doing many changes in the menu config. Is there any way to take all the differences and create a file that could be used, for example, when you share a project to someone?
Yeah, that's a very good point. I definitely will not be, when I put this into a Git repo, I will not be committing the SDK config file, because it may contain things that it contains a lot of information. And even if you even if someone makes changes, like not in the case of this project, because probably I will publish it once and it's never going to be updated again. But if this is a project that multiple people work on, you don't want to look at the diff of such a big file. You want to look at the smaller diff when your colleague is making changes. So for that, we usually commit sdkconfig.defaults into the project directory, and there is a handy command in VS Code, this one, save default SDK config file, and that command will actually create an SDK config defaults file out of our configuration, which in this case you see that those are actually the only options that I have enabled. Yeah.
So basically, those are the differences between.
This is the differences between the default and my current configuration.
Nice.
Okay, so that is set. We have a bigger partition. Let's try again. A partition table occupies 2.1 megabyte of flash, which doesn't fit in configure flash size. I need to also increase the flash size. So let me config again. The partition table, I think the serial flasher config, yeah. Serial flasher config. Wait, where's the... yeah, flash size, okay. So I will set it to, I think the board has 16 megabytes, so I'll set it to 16 megabytes. Let's try to do it again.
So far, so good.
So as you see, the small RTSP library definitely added some size, and also that H.264 stream that we are essentially going to be sending, it also added quite a lot. Okay, so now we are crashing somewhere, and NVS flash init, of course, because I don't have NVS partition. Let's add the partition. Let's add an NVS partition as well. I'm not sure I actually need NVS in this case, but probably let's add it just in case. Maybe later on when I will be adding Wi-Fi, I will need to have NVS. We're flashing again. One thing that happens, as you see here, is that every time we make some change, we have to refresh, and it takes quite a long time. So it's going to still have. It takes quite a lot of time to refresh. So there is a feature that's coming up in I think IDF 6.0 or maybe the next 6.1. It's already partially merged into master, but essentially the feature is called fast reflash, and the feature allows us to not reflash the entire application. If we notice that only some part of the application has changed, let's say you added maybe you added a log line, or you added some small change to your main source file, then we will actually compare the differences between your new binary file and what's already in Flash, and then reflashing can be much faster than it is right now. Now it's not because today I have this workflow based on our VS Code extension, and this functionality is not yet available in the extension. You can only use it in the CLI. I'm not using it today, so that's why we are waiting a fair bit of time every time I need to reflash. Anyway, the application is running again, so let's go to VLC and see if we can open the stream. There is definitely something happening, because VLC actually got the whole image, but it didn't. We are not seeing the stream. And I'm guessing that the reason for this is that I'm passing the entire buffer to the RTSP server. And in reality, what I'm supposed to do is over here, when I call RTSP server send, what I have to do is I have to take like packet by packet. So H.264 format contains sort of packets that are called NAL units, network abstraction layer units, or NALUs for short. And what I'm supposed to do is put one NALU into each RTSP frame. And I'm essentially just sending the beginning of the buffer every time. So I think I'm only sending the first, effectively only the first NALU is being received every time. So I will have to modify the code here a bit so that I actually split the buffer into NALUs. This shouldn't be too complex, I believe. But I will definitely have to look at the code that there is in the RTSP example for that. Small RTSP, yes.
So I see so far no questions from the chat. So please ask questions, suggestions, or just leave a comment about this live session. So this is the first time we are doing this kind of session at developer at the DevCon. So it might be nice to hear from you guys if you're enjoying or things that we could try for the next one. So please leave some comments here in the chat.
Yeah, I definitely have the H.264 string here. That looks correct. RTSP server send. So let's take a look at that RTSP server component we have. So what the RTSP server send does is that it actually should take the data, the length of the data, and it will go into this loop looking for those individual packets within the H.264 stream, the NALUs. I think I will. There are some debug logs here, so let me actually enable those. And the one way we can do this is, the simplest way is just to change them to log I. The other way we can do this is we can go to menu config, and here we can, in the log verbosity, this is not bootloader config, maximum log verbosity we can set to debug. And save that. And then in RTSP main, what we will do is we will change the log level. So we will call ESP log level set level. Keep always forgetting what is the name of this function? So this will be info, and then we will do ESP, yeah, for RTSP server, we will do debug. Let's just confirm that the tag here is indeed RTSP. It is RTSP server, RTSP server. Now we should hopefully be able to see logs from the RTSP server. And let's run that. So my goal right now is to understand why we aren't actually seeing the stream on the VLC side, because we do have the video. Apparently, the connection with the RTSP server is being successful, but we are just not seeing the output. And actually, I noticed that we are at the end of our 3-hour initial guess at how quickly we can make. So I'm definitely we definitely need to practice next time so that the streams go smoother and maybe we have less issues. But that's a part of it, right? Yep. I think what one thing we can say is that the stream was representative of more or less real-world development, because you run into issues that you just don't expect to run into.
Yeah, so we are facing like a real-life situation, and that's how it usually works.
Okay, so now from the spinning of the logs, I see that actually there is something happening. So there is. It's definitely sending stuff, and we are just not seeing much on the VLC side. I wonder if the video actually starts with a bunch of blank, blank frames. One thing that right now is less than ideal is that we are sending kind of all the frames with the same timestamp. In reality, we would be sending frame by frame, and they would have different timestamps. Okay, so I'll keep this plain. Maybe it will eventually move on. Like VLC will basically run out of time showing the same frame, and it will move on. I'm not sure. And in the meantime, I'll just check if there is a quick ffmpeg command to convert, let's say, my single frame image into an H.264 stream, and then maybe I can create a better H.264 stream.
Yeah, so which IDF version is being used? So right now we are on the master branch, so it means this is the ESP-IDF version 6.1.
Dev, yeah, it's development coming up to 6.1. But everything I'm doing would also work pretty much the same way, maybe with fewer bugs, on release 6.0 branch. That is going to be the one that leads up to the...
And there's another question here. Can the CMake or other file check if it's using the correct IDF version to build the application?
Yes, you can do that. In CMake, you can access variables such as IDF version major, IDF version minor, IDF version patch, and then you can alter your behavior based on that. We do this pretty frequently in components that need to be compatible with different IDF versions, and then you can compare the versions and decide, for example, if you want to compile one source file or the other source file, if you want to change the behavior of the program somehow.
And do you need to put the port in the URL?
Yeah, I need to put the port into the URL. Actually, 554 is the default port. Let me just show my VLC window. So see, right now I'm just setting it without the port, but since we do see the connection going, so I'm pretty sure it's not a port problem. It's just the specific way in which we back here, in which we are sending the frames. So I found that I actually can create. Apparently, I can create. If I take a frame, I can create an H.264 file from it. So let me try that real quick.
Yeah, and here the same for the component. You can specify exactly which version of the component you want to use. and this is specified by the manifest file or the requirements file you will have inside your project.
Okay, so what I'm doing right now is I'm just going to bring my terminal over here, so you guys see it. I'm reading how to convert an image to a video with ffmpeg. Obviously, this is a command that you have to look up every time you do this. Frame rate. This is the input, and we need to specify the codec. And the codec is going to be there are many examples how to convert it into some stream that is like a MP4 or something like that. But what I need to actually do is convert it into H.264. Let's try if that works. At least one output file must be specified. CV. I guess it's expecting that I will X264 like that. Okay. That did something. So I have the output.h264, which I'm not sure what it contains, but we can try to copy that and use that instead of the image, or rather the stream that I was using. So I'll copy the output to RTSP server. I think it was in main, and video H.264. Yeah. Okay. So now I have replaced the video. Let's do it one more try. If it doesn't work, then I think it's not a big deal. We can connect once we connect the part with the UVC, it should work fine.
Yeah.
Okay, server started. Let's try.
Oh,
we have the frame. Okay, so that was our original JPEG that we got. Now I've converted this JPEG manually to an H.264 stream, pretending that it's a video. And now we are effectively sending that over the RTSP stream. So we got that part. So if we get back to our original plan where we have the capture, and then we have the conversion, and we have the RTSP, so we now have all those building blocks, and now there's the question of gluing them together.
Yep. So now we know that everything after the USB camera UVC, it's working, and now it's a good point to glue all together.
So maybe we do a 10-minute break, and I think that if there are some people who kind of expected this to end at 1 o'clock and they want to leave, then we thank you folks for being with us, and thank you for the questions that we raised. If someone wants to stick around and see how we actually put it together, and we can wave into the camera and see that on the stream, then you can stay around, and after the break we will continue.
All right. So let's take a break.
I think 10 to 15 minutes probably.
Yeah, 15 minutes, and then we'll be back and glue all together and see some live images being captured and streamed. All right, thank you very much for being with us for this past 3 hours, and then we'll be back, maybe not for more 3 hours.
Hopefully not, hopefully not.
But we'll be back in 15 minutes. See you. Hello, and we are back from the break. And now we will just recap what we did so far, and then we will start like gluing all the parts together, and then try to get the stream working from the camera.
Yeah.
Right.
Okay, so I will get back to this illustration of what we have been doing. We managed to get the USB host working, so that part we have it in the basic UVC stream project. Then we have the second project, I think video processing, that contains these two parts, the JPEG and the H.264, and now we have the RTSP server working in the RTSP server project. So next we have to connect them, and I will start from the bottom. So I will take the RTSP server project and I will add the code from the video processing project to it. And then once that works, I will again go back to the UVC, basic UVC stream project and start taking that code apart and adding it to the RTSP server project. So that's the plan for now. I think the first step is probably going to be relatively simple. And the second step, maybe we'll have some difficulties here, but we will see how it goes.
All right. Okay, so we don't know how much time it will take. Maybe not 3 hours more, but
not.
I hope you will stay with us until the end and to see the final result. And anyway, we will share the code later on.
Yes. Yeah. So what I'm doing now is because as I said before, I've taken some shortcuts, which I probably shouldn't have, and I haven't structured the code cleanly into components. So now it's actually difficult for me to reuse that part from the video processing project because it was just right there as a main function. If I had structured that as a component, then it would be easier. I would just add a reference to that component. But we are where we are. So I will literally just copy the dependencies from the main component of video processing into the RTSP server. In RTSP server, we already have IDF component YAML file, so I add the ESP H.264 here. And then let's look at the code inside the video processing component. So I will probably just take all of that, and then I'll copy that into the RTSP server, and then I will start, sorry, not this one, RTSP main. And then I will start kind of combining them. So first of all, there are all the includes. I also need the JPEG driver. So see there is a highlight that I don't have the JPEG decode file, so I need to add the dependency on JPEG decoder as well. That was over here. And we move it over to here. In our pipeline, UVC, JPEG decode, H.264 encode, RTSP, each runs at different speeds. How do you prevent frame drops if the encoder can't keep up, and how do you avoid memory exhaustion from Q to YUV buffers? That's a great question, and this is something that if I had to do it within the kind of constraints of the live coding session, I would say that you basically want to make things run in parallel as much as possible, because, for example, H.264 and MP and JPEG decoding, H.264 encoding, they all can be handled mostly by hardware. There is some software involved, but a lot of steps are done by hardware. So while, for example, that is ongoing, UVC can be fetching frames. So if we look at that diagram again, then what we want to have is in between the USB host UVC and decode JPEG, there will actually be some kind of frame that's already handed off from UVC to the JPEG decoder. And while that frame is being processed by the JPEG decoder, you want another frame to be already available to USB host UVC. So USB host UVC has internally a queue of frames. And similarly, we will have to make some queues of frames later on, so that while this frame is being processed, UVC can work on the next frame, or maybe it has a few frames just to add some resilience to something else in the pipeline, take it a bit long. Then once the JPEG decoding is done, we can already return this frame, the frame buffer that we got, back into the queue, the frame queue of the USB host UVC, so that it can start filling the next frame. And here, for example, in JPEG, we can also have at least 2 frames, so that one frame is being processed by a JPEG, and at the same time, the other frame is being processed as the input of the H.264. So let's say that this is the frame that was given to the H.264, and there is another frame ready, so that while the H.264 encoder is working, at least you have 2 frames to make the process not blocked. And same for the H.264 encoder. So H.264 encoder will give a frame to the RTSP server, but then it needs something else while the RTSP server is working. You need another frame so it can encode the next one, and then again it has to be recycled. Now you have to make sure that on average all the steps of the pipeline can all complete within 1 frame. So if there is anything irregular to the flow, like for example, maybe we started Wi-Fi connection and due to Wi-Fi connection something in the system got delayed, then you can add more buffers into those queues at the expense of more memory usage, but that will give the system a bit more resilience to something unexpected. But anyway, in the stable situation, everything has to happen within 1 frame. So we have to be able to, in the time between 2 frames, we have to be able to do getting the UVC frame, which we will, decoding JPEG, encoding H.264, and sending it over network. It's a good question, like how do you avoid memory exhaustion? Thankfully on the P4 you have quite a lot of PSRAM, and all those buffers can be in PSRAM, so that helps a lot. And in the very simple implementation, you can just avoid worrying about memory. You can just allocate almost as many buffers as you need. Well, okay, not as many as you need, because for example, for if we do full HD video, then it's 2 megabytes approximately per frame. So if you have 16 megabytes, so you can have like 8 full frame buffers. Thankfully, you only need full frame buffers here on the YUV step between JPEG and H.264. The buffers for NJPEG are smaller, and the output buffers for H.264 are also smaller. So I think we should have enough RAM here, but we are getting into the territory where I would once again suggest looking at some of the frameworks that were built for this purpose, like the ESP capture, because ESP capture will do this for you, and plus it will also handle audio synchronization, which we are not doing any audio today. And if we were to add audio and audio synchronization, rate matching, it would get pretty complex. And this is where you would actually benefit a lot from having that framework. Even though you have to spend some time learning about the framework, that pays off because you have more solid foundation. For today, I think, given that we are already kind of behind on our schedule, we will not be doing those frame queues, although I kind of already thought how we can make it. We will just do it in serial way. So essentially, we will have a queue of frames here in UVC host. This is just the default feature of the driver. We will take a frame out, give it to the decoder. As soon as the JPEG decoder is done, we will return the frame to the queue, and then we will have intermediate buffers for the H.264 encoding, and like the input buffer and the output buffer. And then that buffer from H.264, we will just directly send it to RTSP. So we will not actually have a queue of frames here for the H.264 encoder, at least initially. And we'll see how bad it works. I think that given that H.264 stream is, when nothing is happening in the video, it's relatively small amount of data being passed, we actually can manage to do H.264 encoding and sending over network within 1 frame interval. So it's hopefully going to be good. Okay, let's get back to I hope that I managed to answer the question to some extent. Let's get back to the code. Right now, I was in the process of adding things that we have developed in the video processing component to the RTSP server. So I've already have all the requirements. I've copied the embed files. Embed files was the one that we had before for the RTSP server. So now we don't need it, right? However, we need to embed a different file. We need to embed the JPEG file that we had in the video processing. Here we did this. It's going to be test1.jpg. And I will copy that test1.jpg. So we're here in data. And we put it into the main over here. I wanted to copy it, sorry. Copy. Okay, that is our input JPEG. Now, I think we have the requirements set, and now we just need to combine the code. So I will move this stuff up to the includes. Again, you probably shouldn't have all your code in the single main function, so we are definitely not doing this kind of the right way. But in the interest of time, that's how we have to do it. We already have the ESP log, so that's fine. Next, this is our declaration of the JPEG binary that we have added to the build. We will have to take this app main apart because we have some distinct parts here. So we have some code that's related to initialization. So all this code needs to pretty much run just once. And then there is the other part, which is the actual processing. So this is the JPEG decoder working. This part needs to happen for every frame. And then again, we have the initialization part of the H.264 encoder, which should happen just once. And then again, we have the part which happens for every frame. So we need to take this function apart and initialize some things in the beginning. So I'll create a function. Init video processing and another one. Okay, maybe this can be okay. So that's going to be the two functions. We will call init video processing from main, from app main. So maybe somewhere here. Init video processing, and like again, speaking about shortcuts, all those functions should return an error code, and you should be checking the error codes. But since I'm just throwing ESP error check on anything that I call, this is significantly simplified. But process JPEG frame, and this one goes to the end. So now we copy this part about the JPEG into the init function. We will need to make some of the things static. The JPEG decode out buff, JPEG decode in buff, all those things will have to become static. Again, if you were doing this as part of the kind of preparing for a production application, probably you would put them inside some structure, so it's not just randomly in your static RAM. It's going to be important if you want to have multiple instances of the stream, for example. If you want to do 2 streams at once, or you want to connect 2 cameras at once. So having all that in a structure, like in a context, will allow you to create multiple instances of that, and also will give you easier kind of encapsulation. Now, H.264 input buffer size. This is our YUV image, and that should be for YUV 444. It's going to be width times height times 2. H.264 output is smaller than that, and this is just a conservative estimate for that. The decoder handle we also have to move to the static variables. And let's give all of them the S prefix. Just so that it's easier to distinguish static variables from local variables. Okay, so we have the, once again, let's sort that a bit. There is the decode input buffer, decode output buffer, H.264 input buffer with its size, H.264 output buffer. There is the image size, and there is the decoder, JPEG decoder handle. It's highlighted with red. Let me run reconfigure so that the IDE picks up that we have added the dependency on the JPEG driver component. This is where we initialize everything. All right, and now I have to add the prefix here as well. And we get, again, here we have the prefix. Okay, so that's all the initialization for the JPEG decoder. We don't need these anymore. JPEG BPP. And this is, again, static, static, static. Okay, so I think we have moved all the initialization code for JPEG. Now we move over the initialization code for H.264. This is this part. And there's also the open part, which was my mistake previously. I will keep it as part of the initialization. So the H.264 stuff we just added right over here after JPEG. Again, we prefix all that. We allocate the H.264 output buffer. And that's pretty much it, I think, that we will need for our initialization. So now, over here, I can delete this part because we have already created the JPEG. We will update all those variables to point to the static ones as well. I think I lost the H.264 encoder declaration. I need to get it back. Let me just find the data type for that. It was a handle. And this is the decoder handle, and yes, this is the H.264 encoder handle. Let's add all that prefix here as well. Except the decoder output size, which is a local variable. And here, okay. So we finally have taken apart that main function that we had, and we split it into two functions. The initialization function for init video processing that does right now JPEG decoder initialization and H.264 encoder initialization, and we have the process JPEG frame function that that actually runs the JPEG decoder and the H.264 encoder. We're still using that test image as our source over here. So we're kind of ignoring this JPEG data and JPEG data size. Let me actually take this out and make this function work with its arguments. And then when I call the process JPEG frame, which will be in our streaming task. Where is the streaming task? Yeah, frame send task, right. So over here, we will call process JPEG frame, and here we will use the test JPEG start, test JPEG, and I'm going to start. It's complaining that the function wants to have a unit 8, and of course that array is const. I think I can safely cast it to unit 8t here because I'm not writing into that array, and eventually once we switch from the image and flash, it will work, be fine. And the RTSP send also goes into that. This part gets also into that process JPEG frame. Again, I'm kind of bundling maybe too many things into one function here, but in the interest of time, let's do it this way. So the output buffer is this H.264 output buffer. And the amount of data there is going to be we will have to take from this structure H.264 encoder out frame dot length. And let me just check that that's indeed the data length. It's actual length of encoder data in bytes. Yes, that's what we need. All right, so just make this a bit smaller. Okay, let's recap what we have. We have added two functions, init video processing and process JPEG frame. Init video processing is called somewhere in app main, and that's going to initialize our JPEG and H.264, the decoder and encoder. And then process JPEG frame is called where we used to call RTSP send, and it's going to take the same input JPEG picture, so there is not going to be any motion in the video, and it's going to decode it and then re-encode it to H.264, and then finally call RTSP server send. So right now it's just a bunch of buffers and everything is sequential. So it's probably going to be pretty bad for performance, but that's the simplest way to start. Let's try to build that and run. At least the build successfully. It's,
so that's a good signal.
At least we don't spend time troubleshooting the build.
Right. We have IP.
We have a service started. Let's go to VLC and try to connect. And nothing happens. I think it got reset. So let's go and take a look what happened there. Invalid H.264 handle. Why is it invalid H.264 handle? Did I not initialize it? Maybe I did not initialize it. Let's go back into init video processing. H.264. Ah, yes, of course. Because I need to change this to be the handle that I have allocated there. Okay. Should do it. Let's try again. Okay, we have the IP again. Let's give it a try. Yay! Yeah. And it's working. That was not too long. So now we are sending this frame over and over again, and we are once again getting that frame just from the JPEG test image that we added into the binary. So the next step would be to actually connect. Looks like I have two streams going at parallel. Yeah. Okay. So now we actually connect the UVC part. Yeah.
All right. So it seems the glue is gluing.
Glue is holding so far.
Yeah.
Okay, so now let's take a look at our UVC stream project again. There are going to be again some things that, because the original UVC stream example wasn't structured as a component, well, it makes sense, it's just an example. I will need to manually extract some code from there. So I start with the dependencies. And, sorry. So I add here the dependencies that we got from the example. And next I need to extract some parts of the actual source code. I think I also will need to copy something from the configuration of that example. So there are probably some important things here. I will copy all the USB host related configs because probably they are there for a reason. And I will put them into my SDK config defaults. You know what? First, I will save devconfig so that my SDK config defaults is updated with all the changes that I did recently, like changing the flash size and partition table and so on. Okay, so now it's updated, and I'm going to add the USB host once here. Then, what else do I need from that original project? There is not much interesting in CMake lists, and primarily it's just that there is a bunch of code here that we'll have to copy over. There is a frame callback. The frame callback, I think we don't need to copy this part. This is essentially the function that receives the UVC frame. Okay, maybe we will call this one. It will put the frame into the queue. And right now, our frame send task is triggered by a semaphore, and that semaphore just gets triggered when the client gets connected. So we will change it a bit so that the video stream, like UVC stream, will just start off immediately. We will not wait for the client to connect. Again, that's probably not very energy efficient, but it's simple enough. We will not wait for the client to connect. We will start UVC stream, and then when the frame callback gets triggered, we will put the frame into the queue, and then that processing task, which we have right now as our sending task, that task will pick it up from the queue and then do all the steps that it does right now. So I think the frame callback we will actually keep. Then there is the stream callback. The stream callback looks like it mainly deals with some exceptional situations handling and just logs things to the console. So looks simple enough, so we can keep that. Then there is USB library task. Again, it mainly deals with situations where the clients meaning the, sorry, not clients, devices. The USB devices get disconnected, and we can keep that as well. Then there is the frame handling task. This is the one that we probably will not need, except that we will need a few things from here. There is this UVC stream open, which actually opens the stream initially. We will definitely need that. And then there is this UVC host stream start, which we'll need to start streaming. And so from the frame handling tasks, we will have those two things. Then we have the stream configuration, which we will copy over. And then there is this if example number of streams greater than 1. So we only have 1 stream, so we don't need that. We don't need anything for SD card, so we don't copy that part. And then that's our IPP main. There is some stuff related to driver installation. So all those things, I think we just copy over exactly as they are. So that's the plan. Let's start off with the header files. I think we'll definitely need some of those things. We will need the receive frames queue. We probably need a queue for the received frames just to pass those frames to the processing task. And we will need to have a variable for the UVC stream, so I'll copy that over as well. And as you see, our list of static variables here grows out of proportion. So that's definitely something you don't want to do in a if you're doing an application that's going to be used more than one day. Put those into structure and keep that structure somehow, like as a container for all those variables you create. The frame callback, as we agreed, we're going to keep. The stream callback we are going to keep. The lit task we're going to keep. And then frame handling task, this is something that we will change. So I'm going back to the RTSP main. I'm going to add all those to the very end. This is our frame callback, which we will change. Frame callback. The frame callback was called, I think, from some task. Oh no, the frame callback is called from the UVC driver. And what we do here is we will here it takes the queue from the user context. We only have one queue for the frames, so we can just use our RX frames queue. Did I not rename it? Yes, I did not rename it. RX frames queue. Thank you, Copilot. Queue sent to back frame, okay, and the rest is fine. We don't need to do anything more here. This function will be called by the UVC driver. It's a good idea to make it static. And we can put the declaration on top. Next, so we did everything necessary for the frame callback, I think. Now we have the stream callback. Here are the only changes that I've renamed the variable. I think we probably don't need anything else. I think it's fine as it is. And USB lit task, we also don't need any changes. So those are done. Let's move back to UVC stream. Then we have the frame handling task, which I will do last. This is where we actually will make some changes. Now, the stream config, we use it as it is. There are some macros here. Okay, so the context we don't need anymore. And I am not sure. Yeah, This is probably any BID, and example frame count. Let's see what the example frame count was. The example frame count was 3. Okay, let's copy over that definition as well. It's the number of buffers in the queue of the UVC driver, so how many frame buffers it has allocated. Number of frame buffers, and I think the rest is fine as well. We can keep it as it is. Stream callback, frame callback. Yes, let's keep it as it is.
We can try.
We can try. Yes, we can change something if something doesn't work. Next we have the APP main of the example, and this is where the initialization was happening. So we need to allocate the frame queue. That part we do need. And let's get back to our initialization process. Let's do it before we do the init video processing. Okay. And then there are some steps to initialize the USB host. So I think they probably stay pretty much unchanged. So I copy all of this. I copy all of that. And that goes also. We can create a new function for USB initialization actually. Init video processing. Let's add a new function. And put all the related initialization there. Okay, we are missing some declarations here. Again, there are some macros, and this USB lib task needs forward declaration. So I need this and this. Was there anything else? Was there anything else? Just the USB lib task needs a forward declaration, and the rest I think is fine. Is the lib. Okay, so copy that over to the top. And I think that's pretty much it. It's not everything though, because we still need to start the UVC stream, and we need to open the UVC device, and we need to start the UVC stream. So those are the two other things that we are not doing yet. And then we will need to connect that. So right now the frame callback puts frames into the frame queue. So we actually need to read those frames from the frame queue. So the function where we call the process JPEG frame from the frame send task. So now, instead of taking the semaphore for kind of RTSP connected, what instead we're going to do is, we have to receive the frames from the frame queue. We don't have to delay here, because basically the rate at which we are sending the frame is going to be the rate at which we are getting the frames from the camera. So there is no point in delaying here. We need to do that I can agree with. Queue receive. I think I will want to do it like that. Actually, we don't have to do the timeout here. We can just wait for the frame. And sending frame. Let's just in case put a this is the frame. Okay, so this will work probably. We will process the frame, send it, and then return it back to UVC. I think it's probably going to be nicer if we return the frame earlier in the process. But then we have to make that, because you see right now we are passing just the data of the frame. So there is this kind of UVC host frame structure, right? And to the process JPEG frame function, we are passing just the pointer to the data and the data length. So inside the process JPEG frame, we can't call this UVC host return because we don't have that frame structure. And yeah, that's part of our bad design right now, but it is what it is. So let's try it like that first, and then later we can find a way to move this UVC host frame return into the processing function so that the frame gets returned immediately after the JPEG processing is done and before the H.264 encoding. To compensate for this, we can just add more frames to the queue. So the most important thing is that on average, everything can still happen within one frame, and we can compensate for the delay by adding more frames to the queue. Okay. Frames and task. Okay, let me try to compile it. I think we still are missing a couple of things here. We are still missing that UVC open and UVC start. So that will not be functional yet, but there are going to be some other things defined but not used. Oh yeah, this is because I'm not calling the function that uses that stream config. That's the open stream. And it's also complaining that init USB UVC is unused, which is very helpful because indeed I forgot to call it from ABP main, which I should definitely do. Init video processing, where do I want to initialize USB? I guess I can initialize it before. And I need to do forward declaration for that. Okay, now the only thing that remains, I think, is the part of the logic that was in the frame callback, stream callback, frame handling task over here. There was this part where we did the stream open, and we set the device is connected, and then we did the UVC host stream start. So this needs to happen. And I'm kind of wondering when it needs to happen. We weren't waiting for anything here, so in theory, I think it can happen right after the UVC is initialized. The only difference is that here you see that whole code was within that while true block. So if we fail to open the device, we actually continue and we try to reopen this. I think we can do it like that. We will just need a task so that we can have that kind of infinite loop. The better way probably would be to use a callback from UVC driver and do that, like reopen if we failed to open, right? Not sure. In the interest of time, I think I will just create a task, but there definitely is a way to register UVC callback. Let me create a task. I think that will be just faster. RTSP main. So we will create something called UVC connect task. And in UVC connect task, so we will start the task somewhere in init USB UVC. Task create UVC connect task, okay, and UVC connect task connecting to USB device. Okay, so here's where we have that while loop, and we put all the code here from that while loop. Where's our stream config? It's over here. It's over here. I think I didn't close the bracket somewhere. Oh, yeah. And UVC connect task. This is our mjpeg config, and it's called stream mjpeg config. UVC index is probably 0. Yes, and UVC stream. Okay, fix that. Stream config, and okay, that looks good.
It seems everything is glued.
Yes, almost everything. We need to. I think there are a couple more things. So we have this device connected flag that gets set when we actually connect to the UVC stream. I think that one is not so essential, but we definitely need to make sure that we don't call the RTSP send before RTSP is connected. Yeah. And like as I explained before, probably you want to do this in an event-driven way. So when the RTSP gets connected, then maybe you actually start the UVC stream, and then when you get the frame, you start sending them. So here, because we've already started, or we haven't started, sorry, I need to do some more things. So the stream callback also needs a static, needs a forward declaration. So we're here. And we also need to start the task. The UVC connect task I did already start it. Fine. Okay, so now this task will start up. It will try to connect, and as soon as it connects, it will start the stream. Yeah, and that's right. I should wait here because I don't want to reopen the stream again. And I guess while dev connected like this again, this is an ugly way to do this in RTOS. It should be based on that. Yeah. Reconnection essentially should just be a function that gets triggered by some events.
Yeah, but for the demo, it's okay. If you're developing a real application, probably you will need to handle events and as well, like do the correctly error handling as well.
I think our stream is like everything you shouldn't do when developing a production application with ESP. So maybe we should call it that next time. All right, let's try to compile that. I probably forgot something more that I had to do. Oh yes, I need to check in the RTSP, like in the frame callback. If we don't have RTSP connected, then we shouldn't send the frame over RTSP. So let me do it over here. If not client CTX, we just skip. Okay. Okay, it built successfully. Let's try to flash that.
Meanwhile, I will start a new Q&A here because there is an important thing to discuss, which is, do you prefer light or dark mode on your IDE?
Controversial question. And I will, if the output of the poll is that everyone prefers dark, I will switch to the dark theme. Okay, so we have a failure to open UVC device due to configuration descriptor larger than control transfer max length. I think it could be related to one of those config options that I copied into my SDK config defaults. But if you have been paying attention, I haven't actually done anything after adding them to SDK config defaults. So I need to delete my SDK config file in order for that to have effect. Sorry, I accidentally pressed the debugging thing. Didn't intend that. Okay, now I have. This probably was this option, USB host control transfer max size 4K. That was missing. Okay, and we got somewhere, and then we had failed in an assertion in frame callback. I think I know why, because the assert was there from the original code. Sorry, I'm in basic UVC stream, ESP main. Yeah, I think when we are passing the frame callback, we are actually not providing any context anymore, so we just delete that part. I'm also a bit confused why I'm not why the error messages are not displaying fully. Let me go to menu config again. I do have set it to USB serial JPEG, so I'm not sure what the reason is. Okay, never mind. Hopefully, if something crashes, we will be able to debug that.
Okay. Okay, so some stuff happened here. So first of all, there was some problem opening UVC device, but then it retried, and it did manage to open it, I think, and then got a frame. So there is sometimes USB camera if previously you were talking to it and you suddenly stop talking to it and then you start talking to it again, then it's going to give some error, but it should fix itself after retry. And then we actually got into that frame processing callback, and we ran into this issue. So what the JPEG decoder is telling us is that it detected YUV422, but we asked it to output YUV420, which is not supported. By which is not supported, it means that it's like if the input JPEG that it received internally has chroma subsampling like 422, then you can only ask it to produce a YUV422 on the output. So the JPEG decoder is not internally capable of doing conversion between different YUV formats. So why did it work before? Because apparently, I think the reason is because I was using the JPEG file that I created on my computer, and that JPEG file happened to be a YUV420 JPEG file, so it had like double subsampling on for the color components. But the JPEG frame we get from the camera apparently is 422, which our JPEG can process, but it will also output 422. But then the problem is going to be that when we pass that frame to the H.264 encoder, in order for our hardware H.264 encoder to work, the frame has to be in this format, which is like it's a special version of 420 format. So we will have to do something in between here, between the JPEG decoding. So first of all, we will have to tell the JPEG decoder to actually produce 422, and then 420.
Yeah, so here in the JPEG decoder configuration, we change it to 422. And then somewhere in between that step and the step where we, where's the 264? Yeah, somewhere between the JPEG decoded step and H.264 encoding step, we will have to do the conversion. And for this purpose, we will try to use a component that I remember reading an article on the developer portal. Image effects, yes, this one. Let me bring this over. So there was this article on the developer portal about the component called ESP image effects. And it had this feature, one of the features it has was color space conversions. So you can initialize the color space converter, and you can specify the input pixel format and the output pixel format, and then just say, okay, do the conversion thing, right? That's what we're going to have to do. So again, we are back to the component registry, and we search for effects. There is ESP image effects, and we copy the. Actually, we can just copy that thing, and we can go to IDF component YAML and add that ESP image effects. All right. So there we have ESP image effects. Let's run reconfigure to actually fetch that component. Manifest is not valid because I forgot a colon here. Reconfigure again. All right, we got the component. I think it should be in our managed components directory. Yeah, you see there is this Espressif ESP image effects. And what we are looking for is ESP-IMG effects color convert.h. So we're going to go to our main file. We will include that color convert. Yeah, this one. Then in the init video processing, we also need to initialize this color converter. So somewhere between H.264 JPEG initialization and H.264 initialization. So now actually you see that it's good that I did this in advance, because previously the JPEG decode output buffer and the H.264 input buffer, they were the same thing. Now actually it will no longer be the same thing, because we need to insert that image processing step in the middle. So we will now this is going to be YUV420, so we have 1.5 pixels for 1.5 bytes for each. Is it? Yeah, it should be 12 bits for pixels. So it's going to be times 3 divided by 2. This is the size. And the buffer, we are going to use heap caps malloc. H.264. Okay, so now the H.264 input buffer is decoupled from JPEG output buffer. And in between those things, we can initialize this ESP image effects, which I'm getting already suggestion here. I think it's not getting those in format. So the input format is, it's either YUYV or UYVY. I think UYVY is the more common 422, so I'm going to go with that. And the output is going to be that this one. It says 12 bits per pixel Espressif YUV420. I will, if we get to this working, and there are still some people on the stream, then I can explain what's special about this format, why it's different from regular 420.
This is expressive variation of the 420.
This is specific. Like you can pack 420 data in different ways, and this is effectively one special way to pack it that has been optimized for hardware efficiency, I suppose.
All right.
Okay, so there we have it. We have the color convert handle. I will have to move it again to the static part. And this one is going to be S color convert handle. Let's put it somewhere over here. Right. We have initialized the color converter now in our process frame function. Where was that? Frame send task process JPEG frame. Yes. Over here between the JPEG part and the H.264 part. See if those if those suggestions are correct. Surprisingly, there are no squiggly lines, so it actually looks correct. Buffer H.264. I think this is right. Data length. I don't think color converted. So this is not very interesting log, but let's keep it. So what we are doing here again, the library takes input image and output image as some kind of structures. So there is the. Let's see if there's anything else. There's only data and data length, so that's enough. Our input is JPEG decode buffer. Our output is H.264 input buffer, and we do the color convert process. So fingers crossed. Let's try to run it.
Yeah, and it will work.
I'm pretty sure that sooner or later it will work. Looks like IP4 is too tired.
It's working.
Okay, so it did something for a while, and then it crashed. Let me stop opening Cine because I don't need it right now. It did something for a while, and then it crashed somewhere in some DMA interrupt handler. I'm not sure if it's my fault or not. I'll try to run it again.
It's someone else's fault.
Okay, it's doing something for a while, and then it crashes with the Okay, it's doing something. Okay, let's try to open VLC. At least we are seeing
making progress.
We're seeing the map, so we're definitely making progress.
Let's put a rubber duck on the front and see if it will help.
Yeah. There is something going on with there with the with the number of data units obtained from after decoding image is different from the number. Okay, so maybe I don't need to put an ESP error check actually. ESP error check on the ESP decode, right? It should be in decode H.264 encoder process. Yeah, this part. I guess I will capture it as PRT error, and if error is not okay, this is a JPEG decode error. Because I'm returning the UVC frame back to the driver in the function that calls this one, so I don't need to do any cleanup. I can just return. Let's try that again. Yeah, there was a comment in the chat that's to the effect of that. Looks like something is not working. Let's call it that, and that is indeed a very good observation. Something is not working. So this crash weirdly. So we get this crash inside some DMA function with an interrupt watchdog, but some of the frames are getting processed. It's it would be nice if at least it worked long enough for us to connect VLC, and then we would be able to see the result. Okay. And it crashed again. Looks like that's the final boss of today's.
Yeah, we are almost there.
Today's battle. Okay. Did it crash again? Ah, wait, this is a different. I have more than one window. This one. I can move VLC here. It's weird that it's not. It's definitely sending something, but I kind of wonder why it's sending all the same thing over and over.
Something
again.
related to timestamp, or
could be, or maybe I'm not. Maybe there's something else to it. Okay, but it's promising. It's definitely promising. Yeah. We get something that's not the static JPEG file that we used to have.
Yep.
So, the whole pipeline has something in it, but I think that. Let me see. How is it? What's the flow now? So we have the frame callback. The frame callback takes the frame and puts it into the frame queue. Then we receive from the frame queue into this frame, and we call process JPEG image with the frame data, and then we return the frame back. Process JPEG frame. Let me try to just for a second to set the frame rate a bit lower. Maybe that will help us see what's going on. Okay, process JPEG frame, we have the frame data. We are in fact actually using that JPEG data, and we are... Oh, okay, this we don't have to do. We can just directly use we can just directly use the JPEG data here. So we have this JPEG decoder inbuff, which we don't actually have to use. We will change that to just have be JPEG data and JPEG data size. I'm not sure that has anything to do with the problem that we're seeing. That. Okay, and then we have the JPEG decoder process going. We copy the data to JPEG decode outbuff. Then there is the image color convert process that puts the image into H.264 input buffer, from where we take it and we call the encoder, and it should put it into the out frame, and then we RTSP service send the out frame, and the timestamp is the timestamp. Yeah, how am I doing with timestamp? Yeah, it looks kind of okay. Not sure why it's not moving.
Okay, we have something. And no.
Yeah, it's always, for some reason, we keep sending the first frame. Not sure exactly what the reason is. Let's take a look at the logs a bit. So we get JPEG decoded frame output size. We get H.264 encoded output frame. Found start code sent, frame returned, output frame sent, frame returned. Like, we do get different frames, so you definitely can see that the JPEG, the H.264 encoder output frame size on each frame is different. So that's definitely, we are not definitely sending the same frame over and over. And we are in fact sending those different number of bytes there. It's kind of interesting. It's kind of interesting what the deal is here. Not sure if it's something with the, maybe you're right, it might be something with the timestamps, but the timestamp I'm just getting from ESP timer, so H.264 output buffer, encoder output frame. Yeah, definitely, this is the buffer I'm calling it with, and the length is that I'm printing is actually different, right? So the frame sent tells us how many bytes were sent. So I'm not sending the same frame over and over, unless I have the same frame as the input. But that shouldn't be the case, maybe. Process JPEG image gets called with frame data and frame data length. We're getting the frame from the queue, and we are putting the frame into the queue, and that frame we are getting from frame callback of USB host driver. Yeah, I'm kind of stumped here. I'm not sure what exactly is going on wrong here. Can you check the codec statistics media info in VLC? Yeah, I can. If it doesn't close too quickly, then I can. Where is the video? image, I guess. Kind of details, statistics. Oh, okay, so it's not actually. Okay, so there is some numbers are changing here. So there is the stream bitrate that's changing, and there is the dmuxt number is being increased. So it is receiving something, but for some reason it says that the decoder blocks is stuck and displayed frames is stuck. So it's receiving something, but it's not actually decoding for some reason. It's receiving, but it's not decoding.
You mean decoding on the JPEG, or?
Like the the VLC is receiving the stream, and we see that this number of like how much data it got it keeps growing, and you see there is some number of how many kilobytes per second of data it's getting. But this part, like how many blocks of it has decoded, and it only decodes 2 frames actually. It displays 2 frames and then gets stuck for whatever reason. This looks fine. This is the format. This is the format. Okay, it's interesting. Well, at least it's not crashing this time. That's good. Why would it be just 2 frames? Why would it be just 2 frames? We're definitely sending the data here. Frame send, frame, decoder out frame, length. This is the actual amount of data we got from H.264. Frame send length. Actually, we should have checked this when we did the static image, because we were streaming the static image, but I'm not sure if it was also just sending the 2 frames, or it was the static image that kept updating over and over again.
Yeah, but I think moving back would be more complicated than just trying to understand what's going on here.
If Copilot could help the subject at this time, yes, maybe it could help. Let's try to. Let me take a look again at the RTSP server example code and see if there's something else that I'm doing not quite right. Oh, the other thing that I'm just thinking of is, is our RTSP server actually running? In the sense that when we create the RTSP server, we give it a task, and what is the priority of that task? The task priority is 5, and I think our processing task priority is also 5. Let's try to make it 6. Just something that I'm thinking is that maybe it's just that the task, like the processing task, occupies all the CPU, so the RTSP task doesn't run. That could be a thing.
So we have one more here. Is the JPEG decode actually updating the YUV input buffer before each ESP-8264 encode process?
That could be it actually. Yeah, I think it's still stuck. I thought about that, but see, the thing is that if we look at the logs, then the number of bytes that are being sent from H.264 is different every time. So if we had just a stuck JPEG image, I think that should always be the same, because we are essentially just sending a same frame over and over again. There is probably some randomness to how H.264 encodes, but I don't think there should be that much randomness to it. But it's probably something worth checking. You're right, given that the other H.264 enc process 64 enc process. This is our input frame, H.264 input buffer. H.264 input buffer is the output of the image effects color convert. And the input to that is JPEG decode outbuff, which is the output of JPEG decoder process. I think that we should be updating it. I think we should be updating it, yes. Okay, I'm kind of a bit out of ideas now. I think I would have to, probably if I actually had to get it working, I would now go back to some simpler tests that wouldn't involve UVC and just generate a few frames in YUV format that will be changing, and then feed those changing frames and see, at what point they stop changing. But yeah, I think we probably got not maybe exactly where we wanted to get in this session, in the sense that the app still doesn't stream. It still streams the static image. But I think it was probably most of what we wanted to cover. I can show the application that I developed earlier that is a bit different from this one, but in the way it was written, but it did combine all the same components. And we did get some streams with that. So I will just move that workspace over for a second.
And then we can walk through to this application you have, and but essentially we used everything
all the building blocks that we
all the building blocks all the building blocks that we're supposed to use.
Let's close this one. Now decided to crash. Maybe it's just not. Maybe we have to accept that the demo effect is too strong today.
Yeah.
Let me try again. Okay, there was something moving, and then it crashed again.
Yep, we have something.
Okay, so it works for a bit, and then I think it crashed for the same reason. So I think we have to probably admit that at this point some heavier debugging is going to be needed. I would definitely go and try to find someone who knows about that DMA2D and what that crash might be. I might be doing something terribly wrong in my application. So it might be some sort of memory corruption that probably would take more time to debug. But I think most of the things that we wanted to show today, we were able to show. Semi-hosting was a big letdown for me, because I think it's a really useful tool, and I personally use it quite often when I need to do some processing of data or just to write in test cases. So we definitely need to do some redemption article about semi-hosting.
Yeah, actually, you have a lot of outcomes, right? So articles, more examples. Maybe we can prepare another webinar, so we don't need to wait until the next DevCon to bring more content to you. So we can prepare something, and in between we can do some webinar focused on camera and yeah. So
yes, and as we said in the beginning, we would be very happy to get feedback from you folks, what you liked about the session, what you didn't like, if you want us to try to do something like that in the future, or you are interested in other types of content. And also in terms of feature requests, as Pedro said, if you have some ideas what we should change about some of our components or tools, then that's always most welcome.
Yeah, so it's not easy to do live coding sessions as we did today. Yes. So as you can see, a lot of things could go wrong, but essentially this is how developers usual day goes,
yeah,
right?
I think that was quite representative of how it would normally go.
All right, yeah, and given the time, like we are almost completing like 5 hours live streaming, and also we are of course tired, and I don't know if most of you are following since the beginning, but we showed basically everything we planned to show. And as Ivan said, please leave your feedback. We have many channels that you can use for that. We have the ESP32.com forum. We have GitHub, so we can reach us in many different ways. We will share the list of all the components, all the projects that we use. So we will add this to the video description. So if you are watching this in the future, and if you're not able to see the live chat, so you will see all the links, and eventually even the articles ready. So
yes, we will definitely post all the follow-up content after that, and I'm pretty sure that there will be solutions, let's say, that do basically the same thing that we're trying to do today, just better, right?
Yeah.
From Espressif, ESP, GMF definitely will have an official RTSP solution without all the hacks that we did today, and with kind of proper pipelines and encoding and audio support and all that. So I guess next time we'll have to find another topic that's not yet that well covered.
Yep. Yeah. So if you missed yesterday talks, you can still watch it, and you can check, for example, the ESP ESP capture, and most of the talks yesterday, not most of the talks, but a couple of the talks were related to image, audio, so GMF. So please make sure you check the yesterday's sessions, and I think we are ending another DevCon, the fourth DevCon. So I'd like to thank you all the speakers from yesterday. Thank you very much for preparing this material. I know for some of you it's quite hard to stop the daily routine and prepare this kind of content. So this is part of our work as well, to show what our chips are capable and how we are turning the developer's life easier.
Yeah, thanks. And my thanks goes out to Pedro and everyone who was helping to organize, all the speakers, and of course everyone who has been with us in the chat and watching us live. Thanks a lot, and see you next time.
Yes, thank you.